And coming up on World News, it's almost that time. There you see live pictures from Endeavour. The airlock hatch is open. Astronaut Jeff Hoffman is preparing to come out for the third spacewalk. More coverage when we come back. Stay with us.
Said just a moment ago, the Endeavour's astronauts are now beginning their third spacewalk. Miles O'Brien joins us to sort of walk us through their spacewalk and their mission.
Susan, Endeavour's orbiting optical shop appears to be open for business. Jeff Hoffman is now on the mechanical arm. He is EV number 2, as he is called. He will spend the entirety of the spacewalk at the end, almost the entirety of the spacewalk, at the end of the remote arm on the space shuttle. You can tell him because he'll be at the end of the arm, and also, for those of you who want to have a scorecard at home, he has stripes on his suit. Story Musgrave, his partner on this mission, has a suit with no stripes. They have an ambitious mission tonight. So far, the space shuttle has been very successful in their endeavors. Tonight is an important step in the repair of the Hubble Space Telescope because they're going from turning the Hubble Space Telescope into an efficient spaceship and a more reliable one into fixing that infamous flawed vision. And let's take a little look at some of the NASA animation as to what we might expect tonight from these astronauts. Right now they're just getting prepared, putting some tethers on, getting attached to their foot restraints. They've checked out their suits. They've depressurized the airlock chamber. And if you look at the animation, you can see they pick up this, what is called the Wide Field and Planetary Camera. Weighs about 600 pounds on Earth. Of course, it's weightless in space. It is the primary picture-taking device for the Hubble Space Telescope, and they're going to slide it in much like a drawer. The Hubble Space Telescope was designed to be serviced by astronauts in space. And as a matter of fact, this particular device which they are replacing was going to be replaced anyway, no matter what was going to happen with the outcome of the Hubble. And we're back at a live picture now where you can see Jeff Hoffman on the robot arm working with some of the tethers and tools that he will be working with. The new WIFPIC, Wide Field and Planetary Camera, which is very good at taking pictures of planets and galaxies and so forth, has a prescription ground into it, which is the exact opposite of the flaw in the Hubble Space Telescope, just like glasses and contacts which you get from your optician. And so the idea is that the fuzzy image which enters into this camera will be corrected, and hopefully astronomers down on Earth will be happy about that because they'll be able to see what they've hoped to see, which is the very outer edges of the universe, the very beginning of time, really. Let's listen in for a minute and see what the astronauts are saying. It appears we've lost picture, and that does happen from time to time. The satellite coverage isn't always reliable up there in space. There they are. Are they back? Jeff Hoffman on the robot arm, getting ready to pick up that 600-pound wide field and planetary camera, and he will eventually go and pick up the, pull out the old one. He'll pull it out slightly and then push it back in to get a feel for what it's like to push in the real thing in space. He's been testing in a pool, a tank full of water, and there's an awful lot of resistance there. It's a very different thing in space. And so he will, first of all, pull out the old one, push it back in, see what it's like, then pull it out for good, stow it on the side of the space shuttle, and then go and take care of the new one, put it in, and hopefully, if all goes well, the vision on Hubble will be corrected. Of course, we won't know this for some time.
About how long will the actual replacement take, Miles?
This is a 4-hour...
As soon as they actually started. I mean, they're just sort of doing the prep work now.
Well, it'll be about an hour before they get to it. The whole thing is budgeted for about 4 hours. They'll spend a total of 6.5 hours in space. There is a secondary chore which they have to do up there, which is to replace what are called magnetometers. These are devices which haven't failed on Hubble, but have caused some problems for the Hubble Space Telescope. The devices help Hubble identify where the Earth is. This is not a device which was intended to be operated on or serviced in space, but NASA was able to come up with a plan which allowed the magnetometers to fit over the old ones. So they take the new magnetometers and just clasp them on over the old ones. They unplug the old magnetometer and just plug in the new one, leave the old one unplugged there. It's a very simple task, and the astronauts were sort of trying to draw straws to see who would get this chore, because as you can see, they will be on the fully extended mechanical arm at the top of the telescope, which is 45 feet high, and that's going to be about the best view of the mission. They're going to be able to look down and see the Earth and The space shuttle all beneath them, 370 miles above the surface. So it should be quite a
I can't
sight.
even imagine that. The astronauts, when you've talked to them, are they at all nervous?
No, you know how they are. I'm sure if they were nervous, they would never tell you. But they do. They've all trained for about 700 hours for these tasks. Imagine, I mean, they really basically are simple tasks. It's just the environment that it is done in. And they've trained for such a long time. They're excited about the prospects. And if they have any nerves, you don't see them.
Absolutely. One thing that I'm curious, is it because it's weightlessness? Is that why they move so slow?
I'm sorry?
See them, and they're always moving very slowly.
Yeah.
Why is that?
Well, it's interesting because things that are heavy on Earth, of course, don't have any weight in space, but there is the problem with mass. And not to get into a physics discussion here, but the bigger the mass, the harder it is to stop once it gets going. Because once you push it, it'll keep going indefinitely until you put an equal and opposite force back on it. So what they try to do is move things very slowly and very deliberately, because once you get it going, you better be able to know how to stop it. That's also why they're using that robotic arm. The arm allows them to handle these large tasks much easier than they could if they were trying to walk around or get onto grapples or tethers in the cargo bay. Once again, we still don't have a picture from the shuttle. What happens is they drift in and out of satellite coverage, giving us the possibility of seeing what's going on up there. For whatever reason, we don't have a picture right now at the moment, and I can tell you that right now they are preparing to put in that new whiff-pick camera and hopefully clear up the vision, which has been such a problem with the Hubble Space Telescope.
We do have a picture of Mission Control. Can you tell us, what are they doing at this point? Are they sort of walking them through it?
Well,
what would be happening back on Earth to help the folks up there?
The primary job in the room you're seeing down there is to monitor the platform, the space shuttle. This is where the space shuttle is controlled. There's another room in Maryland which takes care of the telescope. These controls and consoles are concerned with just about every system on the shuttle, including the human systems. They're checking the heartbeat and that sort of thing of the astronauts as well to make sure the machine is running well. As far as the on-scene decisions about what to do with an unexpected problem, many of those decisions are made right on the spot. And as a matter of fact, NASA has encouraged the astronauts to and do the best they can to come up with their own solutions. In any case, we'll continue with live coverage here on CNN of Spacewalk number 3 and Shuttle Endeavour. And just as soon as we have some pictures to show you, we'll bring them to you, and we'll have them for you all through the night with my colleague John Holloman. Susan?
Miles?
U.S. astronauts began their third spacewalk to make repairs on the Hubble Space Telescope. The mission on this walk is to install a new multi-purpose camera nicknamed whiff-pick. The wide-field planetary camera includes lenses which correct flaws in Hubble's main mirror. The astronauts are walking in space to reach the telescope, which has been placed at the end of the shuttle's cargo bay. CNN International plans to bring you extended live coverage of the Hubble repair mission about 20 minutes from now. To report on CNN International, I'm Bettina Lüscher. We want to take you live into space, where the astronauts from the U.S. Space Shuttle Endeavour started their third spacewalk a short while ago. Their mission to fix the Hubble Space Telescope. And what you're watching there are right now live pictures. Basically what the two astronauts have to do in the next few hours is to fix the telescope's bad eyesight, if we put it a little bit bluntly here. They will exchange a camera, and the two people you are seeing floating right now yeah, let's see what they're doing right now.
It's worth all that attention to detail we put in here. We got to thank KT. Put a lot of work getting that in there yesterday. Thanks, KT.
My pleasure, Stuart.
Right.
This is the third spacewalk of this mission, and it's the second one for the two astronauts, Dory Musgrave and Jeffrey Hoffman. And basically what they will do is exchange cameras. They will build in WIF-PIC, that is a wide field planetary camera, and that includes lenses which will compensate for some of the flaws that have been on the telescope Hubble's main mirror. And with that repair, NASA hopes to regain most of the Hubble's lost promise of getting crisp images of the faintest and oldest heavenly bodies.
Back 2 feet. Back 2 feet.
The spacewalk started about an hour ago. And during the next minutes and hours, we should get very exciting pictures. And joining us now is CNN's John Holliman, who will give us more of a running commentary on this spacewalk. Welcome, John.
Bettina, it's nice to be with you again here on CNN International. The astronauts, as you pointed out, got started early. They were supposed to leave the cargo bay of the shuttle about 30 minutes from now, but what they're trying to do is get out into space as quickly as they can after they wake up so that they won't be tired at all at the beginning of their spacewalk. I'm going to get to a position where I can see a little bit better what's going on out there in space. I'll tell you this, there are two astronauts, Jeff Hoffman and Story Musgrave. Jeff Hoffman has his feet attached to the robot arm, which you see in the center of your screen. Story Musgrave is standing on what NASA calls a portable foot restraint. It's a little white pad that has been temporarily attached to the side of the Space Telescope. And if you look right in the middle of your screen, on the other side of astronaut Musgrave, you'll see the edges of a white rectangle. That white rectangle is the outer side of the wide field planetary camera. That's the machine that they're going to be replacing over the next hour to 90 minutes. In order to get it out of the telescope, they have to put something on the outside of it that you can hook a human hand to. And that's what they're doing right now. It's a device called a hand hold. Sort of looks like a wide picket fence. It has 5 or 6 bars that go up and down where the astronauts can grab it by hand, and then there are beams that go across it, which are used to attach it to the back of this camera. This is perhaps the most delicate operation that the astronauts will have to perform over their 12-day space mission. After this handhold is completely attached, there's some latches that hold the camera into the telescope, which will have to be released. Right now, Story Musgrave over on the right is beginning to work on those latches. And what we can do is listen in for a couple of minutes and just listen as the astronauts, Story Musgrave on your right is the payload commander, and Jeff Hoffman out at the end of the robot arm on your left.
Okay, that's good, Clyde. Okay, I can feel I'm engaged. I'm ready for blind mate connectors.
The astronauts have more than 200 tools with them as they do this job. This is a picture from the robot arm itself, looking over the shoulder of Jeff Hoffman.
5.
In the center of your screen, you can see a spotlight pointed at a wrench, which is going through a hole in the side of this camera to release a latch. And there's several of these latches. The astronauts count out each turn of the wrench, Bettina, while they're doing their work, because the people on the ground know how many turns it should take to loosen that particular bolt.
How often have they trained for this?
They have been training, Story Musgrave has been training for 2 years just to do these things. He told us a couple of weeks back that he knows every single move he's going to make when he's outside the spaceship. They have to know every move because they can't afford to make a mistake, particularly with this very delicate camera. As it comes out in a few minutes, you'll see out at the other end of the camera, you'll see a piece of glass, which is one of the most critically ground pieces of optical equipment ever made by human beings. And the piece of glass on the old camera is not that critical because it's going back to Earth and they can replace it. But the one on the new camera, which they'll be installing in about 3 or 4 hours from now, can't be out of alignment, and if they were to break it, it would be awful. Let's listen.
Grounding strap that's located on the outside of the drawer. And the handle is now attached onto the guide studs. That's the handle that will be used to hold it when Hoffman slides the instrument out of the telescope. The instrument's about the size of a baby grand piano.
The voice we're hearing is NASA commentator Kyle Herring. He's at the Johnson Space Center in Houston, Texas. And Kyle Herring told me the other day he too has been training for about 2 years, so he will know exactly what to tell us during the various points in his mission.
So what is new about this new camera?
The new camera has optical instruments that are ground differently than the original camera in order to compensate for the poorly ground main mirror in the telescope. The pictures that we have been able to see from this camera, and about half the pictures from the telescope have come from this camera, have been pretty good pictures. They've been better than a lot of pictures of the planets as seen from telescopes on Earth, but the pictures would have been even more in focus had the new camera, or had the main mirror not been damaged or grounded correctly. And so with this corrective package in there, we should be able to see things on the surface of planets like Saturn and Jupiter that have never before been seen by humans.
And how big is this camera?
It's about the size, as Kyle was saying, of a grand piano. It weighs about 600 pounds on Earth. It weighs about nothing in space. It's fairly large. If you consider the size of a piano, the part that the astronauts are working on is the keyboard area of the piano, and the place where this very delicate mirror is located is at the far end of the piano, farthest away from the keyboard.
And we just have to go now to a short break, but we'll be back in a moment, so stay with us. And we're back here with our extended live coverage of the third spacewalk of the astronauts aboard Space Shuttle Endeavour. And with me here is John Holloman, who is our expert on everything that's floating in space. And
right now, I think that's probably true with you, Dan. What we're seeing in space at this moment is a couple of NASA astronauts who've been training for years and years to do the various repairs necessary to make the Hubble Space Telescope see straight and stay in space and stay in orbit correctly. On the left of your screen, you see astronaut Jeff Hoffman, who is attached to the shuttle's robot arm. The robot arm, of course, is built in Canada, and it is being operated right now by Swiss astronaut Claude Nicollier. He is from the European Space Agency, and he is along on this trip because he has expertise in astronomy as well as operation of this robot arm. And the astronauts continue to disconnect the old wide-field planetary camera from the space telescope. The electrical connections will have to be unplugged, and there's a good bit of work that has to be done before the camera, the old camera, can be removed. It's an interesting system. I guess it follows basic logic, Bettina. What they'll do with this camera after they get it out is they'll just kind of hang it over the side of the shuttle's cargo bay for a few minutes, and then they will open a specially built compartment which brought up the new camera. They'll take the new camera out of its compartment, plug it in to the side of the telescope, and then they'll use that compartment to store the old one for its trip back to Earth.
how difficult a job is this? Is it going to be very tiring for these two astronauts? I mean, they will be floating, so to speak, for hours out there.
Yes, they will. And this is probably going to be the longest planned spacewalk. These astronauts have to be outside, according to NASA managers, at least 7 hours to do this job. And their spacesuits will only work about 8 hours. So if they have too many delays, some of the things that they're supposed to do tonight won't get done. I think it probably is tiring, but the fact is they have allocated 5 nights to do spacewalks, and if these astronauts, for example, were to come back in at the end of this mission and be exhausted, then they might slow down the schedule for the spacewalks. They might give these astronauts a day off so that they didn't have to go back in space 2 nights from now. But the current plan is for them to go back out in 2 nights, and the tomorrow night's spacewalk will certainly be done by another team of astronauts.
So they take turns, I guess that helps.
Yeah.
What can you tell us about the crew, about these two astronauts?
Well, my favorite NASA astronaut is to the right of your screen right now. You can see Story Musgrave's left hand. He is 58 years old, which I think as a 45-year-old man who would like to be an astronaut someday is a pretty interesting thing. He was hired by NASA at the very end of the Apollo era. Musgrave wanted to walk on the moon. And after he was hired and started training to do that, they canceled the Apollo moonwalk program. And they sent Story Musgrave to college. And this man has more college degrees than anybody I've ever met. He's a medical doctor, a surgeon, has a degree in literature, has a degree in physics. He's 6 college degrees. He has almost that many children, and he's been working for NASA steadily for decades. He is the king of the spacewalkers. He knows more about extravehicular activities, as NASA calls these events, as anybody probably on Earth, and has choreographed, as I say, every step of these spacewalking activities for the astronauts. And he's the leader of the 4 astronauts who are outside. The man on the robot arm is Jeff Hoffman, a man who has done 2 previous spacewalks for NASA, a man who is also has terrific expertise in operating outside in the cargo bay in the somewhat more dangerous conditions that are there.
How far away from each other are the telescope and the shuttle?
Well, they're connected at the bottom. The bottom of the telescope is attached to the very rear end of the space shuttle. They made a special turntable for the telescope that flew up with it, and the telescope is now sitting in that turntable. And hang on a second. It looks like there's something going on we should be listening to. Bettina, it looks like I see some movement. Yep. They're beginning to move out the old camera, I believe.
Okay, my lights are good. Go ahead, take me up another 6 inches. Up another 6 inches, Jeff.
Claude Nicollier, you can hear, has a sort of a French accent. That's the way you can distinguish him.
Yes. You want to stop and pitch yourself down a little more? Yes. Yeah, I should. Okay. Okay, I just hold it here, sorry.
One way to avoid exhaustion, Bettina, you were asking about that, for Jeff Hoffman is that he doesn't have to move his body. His body is being moved for him by the robot arm operated by Swiss astronaut Nicollier.
It ought to be in the rail.
You'll hear in a minute, he'll give commands, or he'll say to Nicollier, move me 6 inches to the left, or move me out 1 foot, or something.
Yeah, I think we ought to take it out. I'll redo the pitch, and then we'll come in again. Okay? Yeah.
You see Musgrave there on the right with his hand now inside the wide field planetary camera.
Jeff's story may not be able to get on the rail, so you'll have to really monitor over the top, okay? I can see over the top. Okay. That's why I was having Claude take me up.
The reason Musgrave is in the position where he is, you can see his head, I guess the end of his helmet there. He needs to look inside the telescope to make sure the mirror that's at the far end doesn't hit the wall or hit the sides at all as it slides out. The camera is mounted on rails, sort of like a drawer in your kitchen is mounted on a rail to make it slide smoothly. But there are rails on either side, top and bottom, so that when this thing is locked into place, that mirror at the end and the other optical instruments are precisely aligned.
Who built the mirror?
The mirror for this was built by a NASA contractor in the United States. A lot of the parts were built by the European Space Agency, but this, I think, is an all-American project.
I can grab it if I need to. Okay. No. Go ahead, take it out, Jim. Okay.
Here it comes.
Take it right away. All right, let's move back. Okay, continuing to move back. I'm on the rail.
Musgrave talking about having his hand on one of the rails to help guide the camera out. There's another camera called the Faint Object Camera inside the telescope that is again built by the European Space Agency.
Looking really good.
Where's the new camera at the moment?
It's in the cargo bay, probably 20 feet behind, sort of on our side of where the astronauts are.
Have you let go, Story? No, I'm still there. I'm still protecting. You're all the whole 6 inches.
Musgrave now protecting that mirror.
Okay, take it away. All right, you let go now. I feel it.
In just a minute, they will.
Move back, Claude. Okay, let's pick up the rate, son.
They may, in their original plan, was a plan to push the camera partially back into the telescope that would allow the astronauts to see what it would feel like when they have the new camera, sort of a practice maneuver for that. But at least so far, they don't seem to be doing that.
When I'm far away like this, I'll hold on to the insulated pad. Good idea. Now we're well clear, Jeff. Can I stop? Yes, I believe we're well clear. Okay, stopping now.
The camera's out. The camera is out of the telescope.
Are the other astronauts besides Nicollier also involved in this while this is going on?
Yeah, there are 2 astronauts, Tom Akers and Kathy Thornton, who performed the spacewalk last night. And they are, Tom Akers, I am hearing, talking to the astronauts outside. They're looking through the space shuttle's rear windows. And they're offering suggestions and commentary and helping to relay word from the ground. You can see the sun is coming up.
Brace it against my knees, and that gives me a free hand to get some cooling on.
in space. Beautiful.
Yeah, the astronauts needed to start this process in darkness, and so it got dark 35 minutes ago. And in just a minute, they'll adjust the brightness level on their camera. There you go. And
boy, the cavity just got totally black looking into the sun like this. I can't see it.
you can see the astronauts were talking about looking down back into the telescope, and because the sun sort of blinded them, they're unable to see what's going on in there. This is a picture from the robot arm itself, so we're looking now over astronaut Jeff Hoffman's shoulder. This camera weighs 600 pounds, and it appears to be as light as a balsa wood box.
At what speed is the shuttle going at the moment, if we think about the conditions that these two astronauts are working in right now?
17,500 miles per hour. It is going very fast, but there is no wind, and there is no, there's not much atmosphere there, so they can't feel it. As an astronomer pointed out to me last night, it's almost as if they were falling at 17,500 miles an hour, which is why, that's how they get the effect of weightlessness. Sort of a difficult concept to understand.
Let me play with the handling qualities while we're waiting here. Copy that.
Yes, if they bring it closer back now.
Now you can see it.
Jeff Hoffman on the end of the robot arm with
mirror.
the
Let's listen to
red
Cal
bands
Herring for a second.
on his legs is holding the wide-field planetary camera.
I'll do that too, but I can't do it until the sun moves. Okay.
One of the tasks after removing the camera is to partially reinsert it, and he was noticing that the cavity was very dark because of the sun angle, and he wanted to wait, and that's what he's doing now, and he's practicing some mass handling of the camera to get a good feel for how it moves about in the weightless environment. Story Musgrave is his suit has no stripes on it, no markings, and he's up on the telescope as a free floater during this task.
The telescope weighs 600 pounds on the Earth, and if you look out at the far end of it, sometimes you'll see the end of the camera reflected against the telescope. You can see the mirror. The mirror is not very big, about 6 inches top to bottom and maybe a foot across. And we're getting sort of a side view of it, but you'd be able to see that very delicate mirror. There it is, coming up into view right now. Actually, if you look very closely, when it comes up into the light, you might even see the reflection of the mirror, in the mirror of Jeff Hoffman out at the far end. He's going to...
It looks like the sun ought to be more off our tail in order to keep the whip pick out of the sun.
And NASA is congratulating itself already how the work has been going on for the last few days. But basically, this is a huge repair job, an incredibly expensive repair job.
Yes, hundreds of millions of dollars.
How much is at stake here for NASA?
Well, just to get the telescope working, probably $400 to $600 million is at stake in the effort to fix this. But a lot of people say much more is at stake than that, the whole reputation of the United States space program. Because if NASA managers told me if the astronauts could not do all of these jobs successfully, it would probably signal the end to any effort to try to build a space station using astronauts walking in weightlessness like this. The fact is, the astronauts have proven they can do a good bit of work in weightlessness out in the cargo bay of the shuttle, and that's the way NASA's decided to, you can see light reflecting off that mirror now, right at the far end of the telescope, Bettina, so you can see sort of where it is in relationship to the rest of the telescope. It is a big test for the space program in the United States.
When did they first notice that they had a major problem?
Almost as soon as they turned on the space telescope. It was launched 3.5 years ago in 1990 in the spring.
Camera. This is a task that's designed to give the astronauts a feel for what the installation of the new camera will be like. And again, Hoffman riding on the end of the robot arm.
Take it up. Bring me 1 foot support. 1 foot support. Get the sun out of my eyes.
Claude Nicollier is going to move the robot arm
Hey, Store, looks like you're
to the left.
Does that look better? Yeah, that's a lot better. Hey, how's it look inside the cavity to you? Blind mate and all that. Well, I can't turn that way right now. Why don't you float down and take a look, Story, before we do this reinsertion?
I think that you'll remember a couple of nights ago, the astronauts had a big problem closing a couple of doors over the shuttle's gyroscopes. Those doors are directly between the two astronauts. That latched area where they are having so much trouble is right there, and it appears to be tightly latched.
MLI looks great. Yeah, with my head out of the sun, I can see it there. Looks beautiful.
And Houston copies. Good news.
Okay. Are we ready, Houston? Okay, Claude, let's come in. And Story, I'll yawn a bit to you. Okay. Okay, Jeff, coming in.
Bettina, let's talk about what's going to happen over the next 4 or 5 hours.
Is in a foot restraint
in
mount
about
on the telescope.
in the next 2 or 3 minutes, Jeff Hoffman will attempt to plug this camera back into the telescope as a test, and then he'll pull it out. And about 30 minutes after that, he will park it on the side of the space shuttle. He and Story Musgrave will open up a container that holds the new improved camera, pull it out on the robot arm. It'll look just like this, and they will install it in the telescope. Musgrave on the right will be attaching electrical connectors and the grounding strap and the various things that provide power to the camera, and get the pictures from the camera over to the radio transmitters to get them back to Earth. And after they've done that, these two men are going to get to do something that no humans have ever gotten to do before. The two of them will attach themselves to the end of the robot arm, and the telescope itself will shift in the cargo bay. It will become tilted down. You can see the tail of the shuttle just at the lower right-hand corner of your screen. It will, the top of the telescope will be tilted toward us, toward the place where the rest of the astronauts are, up in the crew cabin. And then the robot arm will be extended up as far as it can go. The two astronauts will be up on top of the Hubble Space Telescope, as I say, higher in the cargo bay than astronauts have ever been before. And they'll be repairing or replacing two machines up there called magnetometers. These are electronic devices. The telescope, to work properly, needs to always know where it is in relationship to planet Earth. And scientists have determined the best way for it to know that is to know where the Earth's magnetic field is. And these devices, the magnetometers, will allow it to know where the Earth is at all times.
About a foot down.
How soon will they know whether this new camera, for example, works perfectly, whether they installed it correctly?
They'll know whether the electrical hookup is done within a few minutes. They won't know whether its corrective optics are in fact correct until they open up the main aperture door on the telescope, and that might take 4 to 6 weeks from now. But they'll know almost instantly when light hits that mirror we were talking about and goes into the camera, because it'll be able to send back pictures instantaneously once the light gets to it from the stars.
Okay, well, thank you very much, John, for coming up here again and joining us here. And that concludes our special report on the spacewalk of the Endeavour astronauts. We'll have more live coverage in the course of the next few hours. I'm Bettina Duscher. Thank you for watching. Coming up next, World News.
Have to go. Oh, 2.5 feet. Okay.
And U.S. astronauts do repair work in space. They're preparing to correct the vision of the Hubble Space Telescope. The program will have live coverage of the U.S. Space Shuttle astronauts as they continue their third spacewalk to repair the Hubble telescope. Please stay with us. Less than 2 hours ago, U.S. astronauts began their third spacewalk to make repairs on the Hubble Space Telescope. The mission on this walk is to install a new multi-purpose camera nicknamed WIFPIC. The Wild Field planetary camera includes lenses designed to correct flaws in Hubble's main mirror. As you can see there, astronauts Story Musgrave and Jeff Hoffman are walking in space to fix the telescope, which is secured at the end of the shuttle's cargo bay.
Probably your pitch, it looks like. Forward. Got to get closer. Forward. 1 foot. Pitch ought to roll you back up.
The unit they're replacing is a 600-pound camera, and they're replacing it with an upgraded version. In the Philippines...
Welcome back to CNN's live coverage of the repair mission on the Hubble Space Telescope. This is the third night of spacewalk for astronauts, And I'll tell you that at this moment they are 1 hour ahead of the schedule that NASA had for what they're doing. Let's listen in now. NASA commentator Kyle Herring was just saying that the astronauts are...
What's left before
Here, let's
removal of
listen.
the new camera is to disengage several latches and bolts that are holding it in place in this protective enclosure before removing it. Again, Jeff Hoffman is riding on the end of the robot arm, and Story Musgrave is the free-floating astronaut in front of the new camera.
Torque 10. And we're still in A3. Okay, Claude, let's move about 3 feet to the port. 3 feet port.
Astronaut Jeff Hoffman there telling Claude Nicollier, the Swiss astronaut who runs the Hubble, or rather the robot arm, to move him on the arm 3 feet to the left. And you can see the robot arm and astronaut Hoffman are both moving to the left in the upper right-hand corner of our screen.
Reviewed your settings there for this.
Astronaut Story Musgrave is standing between us and the new camera that's going to be installed perhaps within a few minutes on board the telescope. The camera is locked in place in this storage container with a series of latches, and one by one those latches are being loosened so that the astronauts will be able to pull the camera out, and Hoffman will hold on to the camera, and Nicollier, the astronaut operating the robot arm, will move him and the camera into position to plug it in to the side of the Space Telescope. Joining us to provide commentary are 2 astronauts who work for the Fernbank Science Center here in Atlanta, David Dundee and Anita Kern. David and Anita, good to have you back again. Last night we learned much from you about astronomy and things that the Space Telescope will be able to do. As over the past hour and a half, we've been watching as the astronauts unplugged the old wide-field planetary camera. What did it look like to you? I remember what this camera looked like in the factory where it was being manufactured, and it didn't look at all different to me than what it looked like 4 years ago, the last time I saw it.
Well, it looked, as you said earlier, like a grand piano coming out, I guess without the keys or stool. I do want to make one comment about the wide field camera as we go along tonight. Although it's called a wide field camera, it's kind of a misnomer. In fact, a wide field camera on the Earth, on an observatory, usually has a field of view of about 5 degrees. The wide field camera on the space shuttle, rather on the Hubble Space Telescope, is only about 2.67 degrees.
So that's how much of the 360-degree circle this camera can look at.
In fact, if you wanted to take a picture of the full moon, it would take about 100 pictures with this instrument in a photo montage to give you an idea of how much an area of the sky it looks at, even with a wide field camera.
Yeah, is this would a camera like this be useful at all on a telescope that was on the Earth?
Yeah, there are wide field cameras used on the Earth for surveys of the sky. There have been a lot of surveys done with various telescopes looking at large-scale structures in the sky. And that's exactly what this telescope will be looking for as well, large-scale structures in our universe.
So this is the camera that they would point at Saturn to let us see what Saturn looked like from the Space Telescope.
Yeah, that's another use for this telescope. This telescope will, this particular instrument on the telescope will be able to look at all of the planets except for 2, the Earth and Mercury. Mercury being too close to the sun to be safely pointed that way.
Well, we're going to continue to listen in as the astronauts go through the painstaking procedure to get this camera out of its storage container and up into the side of the Hubble Space Telescope. One of the reasons that they have to be so careful is that the optical instruments inside the camera are pretty delicate. Anita, what would happen if the astronauts were, for example, to drop this camera as it as they were pulling it out of this storage bin? Could it be destroyed? I mean, how delicate is it?
It's very delicate. And in fact, the tolerance on this camera, because of the added mirrors to correct for the spherical aberration, this particular instrument won't use the CoStar corrective optics. So it has to be the difference between where these mirrors in this camera are located and the light coming from the telescope cannot be off by more than about 2% of the size of, say, a dime. Well, the rails and the tracks that the camera slides in on are just don't allow for that kind of tolerance. So they had to design it to be, once it's installed, to be corrected. And so it's a very tricky procedure, and there's a lot of precision involved.
Yeah, what we're watching on TV right now is astronaut Jeff Hoffman using what appears to be a ratchet wrench. I bet it's much more expensive than the one we use in our projects at home, but he is using it to loosen latches that are holding the replacement wide-field planetary camera in place. And actually what he's doing now is attaching a handrail to the outside of the wide-field planetary camera. When you see the camera mounted on the side of the telescope, it has a very smooth surface. And that surface, the astronauts couldn't grab that surface, so NASA had to design something that would allow them to grab hold of the camera to move it, and that's the rail-looking device that you see there about the middle of your screen. The outer edge of the wide-field planetary camera is the white curved shape that you see at the very bottom of your screen. Astronaut Story Musgrave on your left is continuing to work with the guide rail, get it attached to the side of this camera. NASA told us about 3 hours ago that the astronauts would be doing this job at about 1:30 in the morning Eastern Time. It is 12:37 in the morning Eastern Time, and so you can see how much ahead of schedule they are, or else how well padded the spacewalk schedule was by the planners before the astronauts got to this point in their mission. They work on this schedule, work it out based on how long it takes astronauts working in an underwater tank to perform these jobs. Let's listen again for a minute.
LSV. Thanks, Houston. Okay, I'm going to put the ratchet away.
Jeff Hoffman at the top of your screen is who you hear talking there. The ratchet tool is battery powered, and because bolts in space are difficult to turn by hand, you have to use a power tool. The reason they're difficult to turn by hand, as you can see fairly clearly in this picture, is because of the gloves the astronauts have to wear on their spacesuits. They're almost like boxing gloves. They're so thick. And if you had to use a small tool, it would be very difficult to do it by hand. So they have this fairly exotic electric equipment to do the work. And they continue to make great progress.
Let's come back down, and that'll probably center us out. Okay, launch down. And then I guess
David Dundee, as the old wide-field planetary camera was coming out of the telescope, I noticed the mirror at the end of the camera, and it didn't look that large. It seemed a fairly tiny mirror. What does that mirror do?
At the very end of the instrument, that is the mirror that takes the light from the main Hubble mirror into the system, and the wide field camera then takes that to make an image. By the way, one of the other exciting things this camera can do in the solar system is take a look at Halley's Comet, not just when it passes the Earth, wait every 75 years, but can watch the comet all the time.
Really?
All the way out and all the way back. And that's something we've never been able to do with a comet, to see what happens when it gets in the outer solar system as it loses its tail, and exactly what kind of evolution the comet takes as it moves in the outer solar system far from the sun.
I had no idea it could do that. That's interesting. So it can see things, and there's no way to watch Halley's Comet from Earth, I guess, with anything like the clarity this thing would be able to do.
That's correct. Even with the 400-inch telescope in Hawaii, it would be inaccessible now, just becoming kind of a dot at best.
Let's watch now and listen as the astronauts remove the replacement camera from its storage compartment.
just fingertips.
They have to be very careful. You'll hear them talking about fingertips and inches.
Start on up again, Clyde. Okay, up again, Jim.
Astronaut Hoffman is doing nothing but holding on to it. Another astronaut inside the shuttle, Claude Nicollier, is moving Hoffman's body and the camera because he's attached to the shuttle's robot arm.
Nice and smooth. Keep coming up, Claude. The tanks are in the blind main. Okay, copy. The tanks look good.
Now, the mirror at the end of this replacement camera is covered right now, and we won't be able to see it. It's got a cover on it. Actually, you can see where the mirror is located out there at the end of the telescope. That cover will be removed in a few minutes by astronaut Story Musgrave, and he's going to have to be very delicate in handling that mirror cover, because if the mirror were misaligned, as Anita just told us, by very much, this multi-million-dollar device would be worthless.
Okay, well, actually, I'm gonna do the spin first. If we come up a little higher, Claude. Okay, a little higher, just about 2.5 feet clearance. Go up a little higher.
The protective cover on the end of the new wide field and planetary camera visible as Jeff Hoffman raises it out of the protective enclosure.
This is a time for great precision and delicacy.
Looks like that ground strap's going to stay clear, right, Stuart? Yes, it is. Looks nice. Great.
You can see astronaut Story Musgrave on your left. He's going to pull himself back over to the telescope and help guide the camera into the telescope. He's got to hook up electrical connections. The last connection he has to make is a grounding strap, which just connects the metal on the camera to the metal on the telescope. It prevents static electricity problems. You can see the new wide field planetary camera pointing down with the mirror at the bottom of the camera as it moves very slowly over to the Space Telescope. We're going to take a quick break, and when we come back, we'll see what happens next to the wide field planetary camera and the Hubble Space Telescope as CNN's live coverage from space continues. Stay with us. Welcome back. Two spacewalking astronauts are replacing the wide field planetary camera, main instrument aboard the Hubble Space Telescope right now. This is the picture over the shoulder of astronaut Jeff Hoffman. He's down at the end of the shuttle's robot arm, which you see there. The big white thing on the left of your screen is the robot arm. The Space Telescope is on the right of your screen, and that big rectangular hole in the upper right-hand corner of your TV screen is the place on the telescope where the replacement camera will be plugged in a matter of minutes. NASA commentator Kyle Herring is on NASA Select Television telling us how this mission is going so far.
Timeline in their spacewalk checklist.
In fact, I think you want to, well, let's wait till Story gets in position and then we'll get set up.
You can see Story Musgrave now walking hand over hand. I guess you could say walking, floating hand over hand.
These two astronauts trained for more than 200 or 350 hours in the water.
Now, NASA has put together an animated feature speeding up all of the repair work, this particular part of repair work. You can see now what we watched happen a couple of minutes ago as this handhold fixture was lowered and attached to the back of the replacement wide field camera. The old wide field camera was there on the right of your screen. This is what they're doing right now. They'll soon be removing this cover from the mirror at the end of the camera, and the astronauts will certainly at a speed much slower than this put it into the side of the telescope. And at this point, astronaut Story Musgrave, who would be on the right of your screen, will do some connections, and the two astronauts will slowly but surely push the new camera into place. After they get it into place, they will remove the handholds, and they will go back up to the top of the Space Telescope for the most fun part of their mission tonight. So there's the telescope on the right, tilted at an angle. The wide field planetary camera that's going to be plugged into it, not visible right now, but you can see astronaut Story Musgrave out in space on the right side of the hole where the new camera is going to be plugged in. We can listen as the astronauts talk. And actually, you can see the new camera. It's on the upper left-hand corner of your screen, moving in the direction of the place on the telescope where it will go. Anita Kern, we have heard from NASA experts that it's going to take at least 6 weeks before we know whether this new camera is any better than the old camera, whether it's actually going to work, because we won't get pictures back from the telescope for that period of time. Why does it take so long?
Well, they have to align the mirrors, and they have to, there's a lot of various checkout routines that they go through, both with the computer programming end of it and the actual physical optics of the systems. And so that takes up quite some time to do. And I think they expect the first images back in 6 to 8 weeks. So and these will be some of the first pictures that come back, the ones from the wide field planetary camera.
Yeah. You excited as an astronomer about that?
Oh, yes. We expect to see all sorts of new and wonderful things in much better resolution than we have prior to this point. This particular instrument will produce images that have 10 times the resolution of the Keck telescope in Hawaii. So that's 10 times more detail than what we can see from Earth.
So it's 10 times better than the best we have on Earth, is that right?
Yes, it would be, when we talk about resolution, what that really means is we'd be able to separate two headlights at about 3,000 miles.
On a car.
On a car, right?
and the other thing we should point out is that when you take pictures with this particular instrument on the telescope, there's no physical film inside or videotape. What is at the end of this optical system is a sensor. It's called a CCD, or a charge-coupled device. And basically what that does is takes the light that enters the system and translates that into an electronic image. And that electronic image, it can then be beamed down to Earth and processed through a computer one way or another. And it's interesting that many of the telescopes, ground-based telescopes now, are using these kinds of CCD devices because they're far superior to using film as astronomers have done for about 100 years.
Yeah, those CCD devices are much more expensive and probably much better, but very similar to the same kind of devices that are in the very back of the TV camera that you're looking at me on right now.
Actually, on the long range, the CCDs are less expensive because you don't have to worry about film or developer.
Yeah, exactly. It'd be hard to get the film back to the local Kmart to get the 2-for-1 offer, I suppose, from this camera.
No mailers.
Yeah, look, we're going to take a break at this moment. The live picture from space has gone away for a second or two. The astronauts are just ready to accomplish what astronomers say is the most important thing they're going to accomplish on this mission in space. Stay with us. We'll be right back. Welcome back. The astronauts aboard the Space Shuttle Endeavour having another good night in space. They have been outside the shuttle now for about an hour and 52 minutes. They're well ahead of schedule on replacing the wide-field planetary camera aboard the Hubble Space Telescope. The old wide-field planetary camera, which, by the way, was working very well, was taken out of the telescope and stored, is now just hanging over the side of the shuttle, attached by a couple of guide wires. And a new and improved version of the camera, which has new optics designed to compensate for the problem in the telescope's main mirror, is out in space. It's on a carrier in the hands of astronaut Greg Harbaugh. Harbaugh is about ready to plug it into the side of the space telescope, but I would be willing to bet you he does not do that while the shuttle is not in communication with the ground and while we are not able to have live pictures from space. Those live pictures, we're told, will come back in a matter of about 5 minutes. And when they do, we'll go back to them, of course. I'll keep one eye on the NASA satellite feed and the other eye on you there. Let's talk about how much better the new camera might be than the old camera. Anita Kern, you've seen the pictures from the old version of the wide-field planetary camera. And how do you feel about how much better they're going to be when this camera's fixed and checked out in a while?
Well, you know, the old camera took about 3 10-minute exposures of the Orion Nebula. This is a dust cloud that is a stellar birthplace in the constellation of Orion, and it did detect matter and debris, actually rings around about 15 stars that may indicate a formation of a planetary system around those stars. But the exciting thing was it saw very wispy structures that had never been seen before. And of course, astronomers were both thrilled and frustrated by this because with the old camera, they didn't really know if they were really seeing structures or if it was some artifact or problem that was coming out of the computer processing of the images. So now with the new camera in place, we should be able to determine that. Also, with the new camera, the sensitivity of the coatings on it should improve the coatings on the new camera should improve the sensitivity by about a factor of 2.
Yeah, I'd like you, Anita, and David Dundee to join me and watch very carefully as astronaut Story Musgrave, who you can see there on the right of your screen, attempts to take the cover off the pickup mirror out at the end of the Space Telescope. This, I believe, is going to be the most sensitive part of the job tonight. This is the only time that a human being is ever going to touch a working part of the Space Telescope. And Story Musgrave is under orders to be very careful not to do anything to damage the mirror as he takes this protective cover off. Let's listen into the NASA commentators, and if the two of you see anything that pleases or displeases you, let me know.
Let me look at the A-lanch. Look at the threads and A-lanch.
You can see Musgrave's spacesuit has 2 spotlights on it that are shining right at that mirror cover.
Hey, Jeff. Okay. Are the brakes on, Claude? Brakes on, Jeff. Okay, we're holding steady. Putting in the pull. The aperture door open. Copy.
Okay, he's beginning to hit a latch on the mirror cover. All of these, here it comes. Oh no, a moan from everybody here as the satellite coverage from space went away. We're going to have to wait until we get picture back to see how that did. We'll take a quick break and we'll see if the satellite gods will allow us to get the picture of that cover on the mirror being removed. Stay with us, we'll be right back. Welcome back. We've just gotten our live picture back from space. Let's go to it right now as the Endeavour astronauts continue their work. Right before we took our break, astronaut Story Musgrave was about to remove a cover from the pickup mirror at the end of the new wide-field planetary camera. He says he got it off without problems. Let's listen now as the camera is prepared for pushing it into the side of the telescope.
I'm ready. Okay, let's start in. Okay, I'm moving out now, Jeff. That's 3 feet. About 1 inch per second.
I think it's safe to say they didn't break the mirror because they're installing the new camera right on schedule. As those of you who were watching 5 minutes ago noticed, at the very instant that he began to remove that cover, we lost our picture from space. And when the picture returned, the mirror cover was off.
I'm on it. Okay, keep it coming. We're going in the entrance. Just keep it coming. This is smooth enough. We're just going to let it come. Let it come. A little higher. A little higher, sorry. There we go.
On the right of your screen is astronaut Story Musgrave. He can see inside the telescope, and he's looking at that mirror to make sure the mirror doesn't hit the side or doesn't hit anything as it is reinstalled at the end of the wide-field planetary camera.
Keep it going in. I'm keeping the top just about an inch below the envelope. Okay. Got to think about those 4 bolts on the bottom. Yep, they're clear. Looking good. I'm on the handrail.
There are 4 rails that guide this camera into place on the telescope, and it's on the rail. Musgrave points out that the camera is on one of the handrails right now.
Okay. I'll go to the outside. Oop, oop, oop. Okay. Let me stabilize.
Hello, and now we resumed our special live coverage of the 3rd spacewalk of the astronauts of the U.S. shuttle Endeavour, who are now on the 6th day of their mission, trying to repair the U.S. telescope Hubble, which has been severely hampered in some of the things it can see. And you can watch live pictures now And in a moment, CNN's John Holloman will take over with his wonderful running commentary of everything that is happening.
Endeavour Houston, we would like the ground strap secured, not touching the connector.
Copy that. Yeah. I'm finding if I just tap it a little bit.
Metal on the camera to metal on the telescope is about to be attached by astronaut Story Musgrave or Jeff Hoffman. We'll listen as they do that, and as soon as they do, that will be a very good sign. Once again, we have to depend on satellite technology from NASA and from the U.S. government to provide us with live pictures from space. And there are times when the satellites are not in position with the telescope to provide us with live picture. But we have a couple of astronomers from the Fernbank Science Center in Atlanta who are joining us also to provide commentary on what is happening and what it all means. Anita Kern, we were talking about the reasons to have something like the Hubble Space Telescope. As astronomers, would you and David like to see different telescopes in space? And do you think, given budget restraints in the United States and in other countries around the world, we are ever going to see telescopes better than this in space?
We see a lot of different types of telescopes. There are telescopes up there that are specifically designed to look in the ultraviolet part of the spectrum. There are some up there that look in the infrared part of the spectrum. So we do have both probes which take pictures of the solar system and various planets, and like Mars and the Voyager flybys of Jupiter and Saturn and Neptune. And so we are seeing lots of different things in space that are sending back information. It's just the quantity of information that's expected back from Hubble should keep everyone busy for a long time, and it should be a lot greater than what we've seen up to this point.
All right, to bring our international viewers up to date on something else, the Space Shuttle Endeavour and the Hubble Space Telescope are out over the Atlantic Ocean. They crossed over Central America a few minutes ago. The light that you see on the side of the telescope will continue to get brighter as it approaches Africa. Our viewers in Africa might want to look up in the sky, and you might be able to see this spacecraft coming overhead in the next 10 to 15 minutes. The astronauts are getting more brightly illuminated now. We'll listen to Kyle Herring from NASA for a moment.
The final connection, the blind mate connection, turning that bolt about 5 turns or so.
Down to. And Houston, we show about 4 minutes to sunrise. How's our attitude going to be on the STS doors?
Okay, the astronauts are about to come into sunrise, and while they wait for the sun to come up, we're going to take a break. We'll come back and show you what it looks like as the Space Telescope with a brand new camera sees sunrise for the first time with that camera installed. Stay with us. Welcome back. I'm John Holloman. We're covering the mission of Space Shuttle Endeavour to repair the Hubble Space Telescope. One of the interesting things about being an astronaut is that you get to see the sun come up a lot more in space than you do on Earth. Those of us here on Earth, since this mission started, have been able to see the sun come up 5 times here on the east coast of the United States. We'll get to see it again in a few hours from now. Those of you watching in Europe have already seen a sunrise today. The Space Shuttle astronauts are going to see their 74th or 75th sunrise during the same time period in just about, well, there it is. You saw it occur as the sun hit off the tail section where the orbital maneuvering system of the space shuttle is located, and there's the first sunlight on the Hubble Space Telescope since its new wide-field and planetary camera was put into place just a short time ago. The astronauts are now, they've completed the job. It's been checked for electrical continuity, the lights work, and that's a good sign. We've invited you to join our conversation by phone, and we have a couple of astronomers here who are very smart about astronomy, and we have one correspondent who will try to answer other questions if possible. We have a caller from Ohio. Go ahead, please.
I was wondering, well, actually, I've got a couple questions and a comment here. I was wondering, I've got a scanner here, and I was wondering what megahertz NASA uses to communicate from the ground station up to the shuttle. And
they won't tell us. They don't want us to listen in. I've tried to get that frequency for a long, long time. It uses the tracking and data relay satellites, which are also used for spy satellite communication. And so it's hard to listen in, I'll tell you that. It's the fact that we can put it up on CNN, I guess the best way for all of us to listen in.
Okay.
What's your next question?
I was wondering how they're going to pretty much like turn the telescope on its pitch and yaw axis once it's finished and it's back in orbit. I was wondering what the propulsion units are on that.
I don't have the answer to that. I can find out for you. You all know?
Well, there are no propulsion units on the telescope itself because you don't want to have anything to pollute the equipment on the telescope. So what they do with the arm is they gently move the telescope to the proper altitude and place it and let it go in the proper place, and then the shuttle gets out of its way, basically.
Okay, I'm listening to NASA right now, and we find out that astronaut Story Musgrave is closing a door next to the Wide Field Planetary camera. It's a door he was able to use to look through while that camera was going in. It's the door that contains the fine guidance sensors for the telescopes. Those sensors allow the telescope to point at the thing that ground-based astronomers want to look at a particular time. Okay, we're going to take a quick break, and we'll come back with more phone calls as the astronauts are continuing to work outside in the cargo bay on the Space Telescope. As they get a little bit further along in this orbit, we'll probably be able to see our own planet down below as they fly overhead. Back in a minute. Stay with us. Welcome back. Space Shuttle Endeavour is flying over sunrise now, over planet Earth. They've completed a major part of their mission for the entire 12-day mission, actually, replacing the wide field and planetary camera aboard the Hubble Space Telescope. This picture, by the way, is being taken from a camera which is mounted about halfway down the Canadian robot arm. At the far end of that arm, you can see astronaut Jeff Hoffman, who has already pulled out the original wide field camera for the telescope and has used the same arm to plug in the new camera. The new camera has been tested electrically, and from what we could see, it appeared it wasn't jarred or anything to mess up the optics inside. This camera is going to be able to do things that that the telescope couldn't do previously, we are told. And we'll be talking about that with our two astronomical experts, Anita Kern and David Dundee, as the morning continues. We have some phone callers on the line. Our first one's from Ontario. Go ahead, you're on with us.
Thank you very kindly. I'm Joe Pizzola calling from North Bay, Ontario. Thanks for the plug for the Canadarm, and thanks for the opportunity to utilize an interstellar medium like this. I have several questions, a million of them actually, but in the sake of time, John, what happens to the old WIFPIC, the Wide Field Planetary Camera, for Mr. Dundee and Ms. Kern? What, as astronomers, are they specifically looking for to learn from Hubble? And does the CNN crew have any of Hubble's earlier pictures on file, and maybe can we see them later?
Wow, what an interesting question, Joe. We just, this moment, put together a picture, an older picture of Saturn taken by the Hubble Space Telescope, which we'll probably be able to show you in just a minute. The old camera is going to go back to the factory, and I'll bet it'll be updated again, and it might even conceivably be reflown on a shuttle with even more new parts inside to do the third generation job of wide field planetary exploration. Now, in our picture on TV here now, you can see over Hoffman's shoulder as he continues to work around in the cargo bay. And the astronauts, as we can tell, continue to be having a pretty good time out there as they've got sunlight down below.
Two astronauts are swapping.
Okay, let's listen just for a second to NASA, then we'll let our astronomers answer your astronomy question.
His to Musgrave to allow him to complete closing the fine guidance sensor door. The fine guidance sensor is located in a radial cavity, just as the same size that the wide field and planetary camera is. It's located about a quarter of the way around the telescope.
To look into the side of the telescope when the camera was being replaced there. Our next caller, forgive me, we had questions about astronomy, and we have astronomers who know it all. Go ahead.
Some of the objectives of the Hubble Space Telescope are to determine the size and age of the universe, and they do that by looking at things in the very distant past and that are very far away, like the quasars, and they're trying to determine maybe how galaxies evolve. That's one of the things that we hope the wide field planetary camera, when it images these very distant objects, may even see structure of galaxies around these quasars, which are very old objects.
Yeah, if you can find structure around the quasars, it may give you some sort of evolutionary link between these ancient objects and more modern galaxies we see today. And it may start filling in some of the gaps we have from the birth of the universe to the kinds of matter we see around us. The other things that the Hubble will be able to tell us will be things like looking at the nuclei of very active galaxies. How many of these active galaxies have black holes in them, massive black holes, perhaps causing disruption of the galaxies hurling out material? How many of these galaxies show evidence of collision? We're finding in some of the very early Hubble information that apparently a lot of these strange-looking galaxies we see may have suffered collisions. I also want to say that some of this information, much of this information, by the way, will probably get into the public domain fairly quickly. One of the things that's happened over the last few years is a real information revolution with the advent of personal computers and things like CD-ROMs that can store a lot of information. And for example, most of the images off the Voyager spacecraft are available to people in the general public. They can buy them or find them in some of their larger libraries to look at. And you might even make your own discoveries looking at some of this information. You don't have to be necessarily an astronomer sitting at the Hubble Space Institute.
Yeah, it's one of the interesting things about being able to see these pictures on CNN as we continue to watch the astronauts work in space right now. We may make discoveries about the telescope. I know that 2 nights ago, after the telescope was first attached to the space shuttle, an astronomer and I were looking at it very carefully to see if we could see any signs of damage. And we discovered none. It turned out the astronomers and scientists at NASA also discovered none, and our viewers discovered none. The other thing our Ontario caller asked about was a picture from the Hubble Space Telescope taken before the new wide-field and planetary camera was installed. We have one to show you. It's a picture of Saturn that was taken more than a year ago by the Space Telescope. And, well, you can see the grainy nature of it. Anita Kern, looking at this picture, according to NASA, there's a planet-wide storm across Saturn.
That's the large white area that you're seeing there.
Yeah. And
actually, Saturn is mostly hydrogen with some impurities, and the white area you see, of course, it's all gas. The white area would be ammonia crystals, and the darker brownish area underneath it is probably due to methane.
Now, let's anticipate a similar picture taken with the new wide-field camera. How much clearer might it be than that?
Oh, it should increase by at least, the sensitivity of the new camera is supposed to increase by a factor of 2, so we should see much more detail.
Not as many white dots, much more clearly defined edges on things.
And the nice thing is we'll be certain of it. I mean, right now we're not really sure if the features we're seeing could be artifacts or caused by the deconvoluting process that's in the computer program.
Yeah, let's talk about what's going on in space right now. On the left, Jeff Hoffman, at the end of the robot arm, is up at the back of the wide-field planetary camera, the new and improved model. He's removed the handhold from it, and he's just doing a little work out there, making sure it is correctly seated. It certainly appears that it is. Story Musgrave, on the right of your screen, you can sort of see him outlined against the tail of the shuttle, is removing a foothold, a piece of equipment that was used earlier in the mission, and he's closing a door there that was used to help him have a look inside the Space Telescope just a few minutes ago. The next thing that the astronauts are going to be doing, by the way, is both of them will go to the end of the robot arm, and they'll go up to the top of the telescope, which will be tilted at a slight angle so that the astronauts can add some new equipment up at the top of the telescope. Should be interesting TV to watch. Our next caller is from Toronto. Go ahead.
Hi, I have 2 questions to ask of you. The first one would be, could this detect any kind of extraterrestrial spacecraft in our solar system or another one? And if it could it beam radio wave or receive a radio wave in the direction of that?
No, there are no radio detectors on the Hubble spacecraft. As far as being able to see a spacecraft, it would have to be pretty big or extremely bright for
or
the
close to the telescope, right?
Yeah, if it landed on the telescope, we'd probably know about it. But in general, no. The Hubble is not a good one to look for spaceships.
Everything's going well aboard the shuttle Endeavour right now, we are told. The astronauts have completed the major task that they were supposed to do in this 6 or 7 hour long spacewalk. And we're going to take a break. We'll come back with more of your phone calls and more of our conversation about what's happening and why it's important as CNN's coverage from Endeavour continues. We invite you to call us from wherever you are around the world at this moment. We're covering the Hubble Space Telescope repair mission live on CNN. At what you see at the center of your screen at the very bottom is the old wide field and planetary camera, which was removed from the Hubble Space Telescope about an hour and 15 minutes ago. We have phone callers lined up from around the world now. Our first call is coming in from Alaska. Go ahead.
Yeah, hello. My name is David Saidet, and I'm calling from Cordova, Alaska, on Prince William Sound, where the Exxon Valdez oil spill is. And I have two questions regarding materials. I was wondering what the specific material his tether is made of that holds him to the ship. It looks like ordinary household cable, but I'm sure it's not. But I'm wondering what kind of material it is that can withstand those 500-degree swings in temperature from night to day. And then second, I was wondering what are the increased risks from radiation, ultraviolet and cosmic radiation, and what kind of materials is the outside of his suit made from to absorb those radiation rays?
Okay, the cable, the tether that's holding him to the side of the space shuttle is not an ordinary household cable. It would be a lot less expensive to do this if it were, probably, but it might not work as well. It's a composite material. It's woven, and it is very strong, and they've had no trouble, actually, with it withstanding extremes of temperature to this point. Geez, can I remember the other part of the question?
Cosmic rays were part of it.
Yeah, cosmic rays.
Cosmic rays, unfortunately, whether you're in space or sitting in your living room, they zip through your body and through the Earth quite readily. So there is no shielding from cosmic rays.
You know, an interesting experiment that NASA did that got a lot of publicity about 2 years ago on many shuttle missions. I mean, a series of maybe 6 or 7. NASA flew a human skull which had cosmic ray detectors inside of it. I mean, it was a bizarre story when we first heard of it. And that was done to see whether over a long period of time the cosmic rays would get into the central part of a human skull. And it turned out, I think, from the numerous flights over more than a year that this skull was in one of the crew compartments of the shuttle, that they found that there was no terrific increase in radiation damage. Our next caller is from Edmonton. Go ahead, please. You're on the air.
Hello, my name is David Prakashan, and I'm calling from Edmonton, home of the Oilers and the Eskimos. First, I'd like to extend my best wishes to everybody involved in this endeavor. And what I'd like to know is the names of the astronauts and their area of expertise, and how many space agencies are collaborating in this effort, and are the Russians involved? Thank you.
Okay, the Russians are not involved in this particular effort. However, an announcement was made today, or yesterday, depending on where you are on Earth, that the United States and the European Space Agency have agreed to cooperate with the Russians in future space exploration efforts, and the prospect of having a joint space station involving the Europeans, the Americans, the Canadians, and the Russians is much more likely than it was as much as 6 months ago. Look at this picture with me, please. What we are looking at is astronaut Jeff Hoffman on the end of the shuttle's robot arm. He's outside the space shuttle cargo bay in space. He is standing on the robot arm over the tail of the space shuttle, over the rear wing. And to his left, you see the original wide-field planetary camera. He's about to put the mirror cover on the small mirror that you see that looks sort of like a fish hook out at the end of that camera. And we're going to zoom in and watch as he does it. This procedure is just as critical as it was when Story Musgrave replaced the mirror cover from the brand new camera a few minutes ago. Why don't we watch and listen as this happens, and then we have another caller from Birmingham, England we're going to talk to. But let's watch this before we go to our caller in England.
Let's come down about 1 foot. Okay, Jeff. 1 foot. I should open the door and wait till Jeff gets to that with big one. Stop. Stop. I think you probably go ahead, Store. He's going to be ready in just a couple of minutes. Yeah, I was thinking of the clearance back there. Looks okay. Yeah, I think it clears when it's open. Yeah. Hard pushing this in. When I hit the mirror. Want to get this closer, Jeff? No.
Another critical
Jeff,
procedure.
Your helmet. Would it be better if you were lower? Well, yeah, okay. Let's bring me in, and I'll stand up more upright. Oh, I can. Just bring me further in. This way my helmet will stay further away. You showing me? I can pitch your body up. I'll switch you in.
Claude Nicollier is operating the robot arm on which Jeff Hoffman is standing, and he's pushing him in to the wide field camera now.
Keep coming in. Stop.
Now, this is going to be critical. Got to make sure that that mirror, the tiny mirror that you can't see now, it's obscured by Hoffman's space helmet, does not get hit or damaged in any way. This maneuver just as critical.
Houston, Tom, Story is good. Open the RSIPE door when he's ready.
Just a minute. As the maneuver to take the cover off of the other mirror, but one nice thing about this, if this mirror is broken, the telescope isn't out of business. You can bring it home and get another one and put it on there.
Story, I wonder if that switch has to be on back by the soap to get those lights. You know, that work light switch.
This particular spacewalk is being conducted out over the rear wing of the space shuttle, and it's quite something. Why don't we do this? We have a caller on hold from Birmingham, England, who has been waiting, spending a lot of money for several minutes waiting to talk to us. Let's get that caller in, then we'll come back and tell you who the astronauts are and where they're from. Go ahead, Birmingham.
Hello, good morning, John. First of all, I'd like to say thank you to CNN for the extensive coverage that I'm receiving over here. It's the only American channel I can get with some good pictures. But basically, what I wanted to ask you was, as the orbiter is on, if I'm right in saying, orbital track 46, which like sweeps across the world, can you briefly explain why it does the track it does? Say it goes through Central America, down to the south tip of Africa, then over north of Australia.
Yeah, the track that it's on is based on where it's launched from, basically. And it was launched, it can be launched in an orbit that takes it much higher. It's come over the British Isles in the past. But for this particular mission, the space shuttle had to be launched in the identical orbit to the Hubble Space Telescope, because they didn't want to adjust the orbit of the telescope, and they wanted to make sure that the shuttle could get to the telescope. So one of the reasons that this mission is taking place in the middle of the night, United States time, is that they had to launch when the telescope was directly over Cape Canaveral in Florida. And it was only coming over Cape Canaveral at a period of, the first potential launch day was 4 o'clock in the morning. Ah, this is great, home movies, or home snapshots being taken by astronaut Hoffman as he moves away from the old wide-field planetary camera. Look at this. Yeah, I wonder if NASA will develop those for him, or he'll have to take them to the drugstore. This is something.
Would you verify that your light signature was not affected by sunlight?
Yes, Story and Jeff both looked at it. You're pretty positive, Story, they're not on, right?
The camera that's taking this picture for us, by the way, is located about halfway down the Canadian robot arm.
Yeah, we've seen them in daylight in the clean room, and there's no lighter out there right now than was in the clean room.
Okay, Tom, we understand, and be advised we are getting indications on the ground.
Okay, copy.
There will come a time, I would bet in the next 4 to 6 months, that these pictures that Jeff Hoffman are taking will be made available to the rest of us. The astronauts have an IMAX camera out there in the cargo bay. I'm not sure that this is the viewfinder and the lens from the IMAX camera. In fact, I don't think it is. It appears to be a still camera. If it were connected somehow to the IMAX, it would have to Well, it just couldn't be. It's got to be either a small video camera or a still picture camera. You can see it's protected with white packaging to keep it from being damaged out there in the vacuum of space.
There are two IMAX cameras on the...
All right. While Jeff Hoffman is making these movies or these still pictures, whatever they are, of the wide-field planetary camera, which I hope we'll be able to show you in the next 3 or 4 months, we're going to take another break. We'll be right back. The Hubble Space Telescope may now be able to see straight. We're not sure, but certainly the wide-field planetary camera that was being replaced in tonight's spacewalk has now been replaced. The new camera is in place. The astronauts have checked out the electrical connections. The lights are on inside the wide-field planetary camera. And out in space right now, the astronauts are about 320 miles above the Earth. They are in darkness, and we don't have live picture from them at this moment. But the astronaut team, Story Musgrave, and his partner, Rick Hoffman, they're out there. They're doing their best at this point to accomplish the last goal of this night's spacewalking mission. That is to go up to the top of the Space Telescope and add a couple of pieces of equipment called magnetometers to the Hubble Space Telescope. These magnetometers will allow the telescope to figure out where the Earth is in relationship to the Hubble Space Telescope, and that'll keep it on course as it continues its mission to look out into the heavens. Our coverage will continue throughout the night as long as the astronauts are outside and we have live pictures to bring to you. We will bring them to you. Our viewers ask who these astronauts are, and we don't have time to go through complete rundowns on all of them, but I'll tell you about the payload commander, the man who's been doing much of the work outside during the current spacewalk. Story Musgrave, 58 years old, a man with numerous college degrees, more than 5. He's a medical doctor. He also has a degree in literature. And he's the leader of the spacewalking astronauts. Musgrave said a couple of weeks ago he's choreographed every step of this mission, and it certainly is going well, perhaps as a result of that. Our coverage will continue coming up in a few minutes. We urge you to stay with us. CNN's coverage of the mission of Space Shuttle Endeavour continues. I'm John Holloman reporting.
Hundreds of miles above the Earth, with more of CNN's extended live coverage of the Hubble repair mission. 2 Endeavour astronauts have been working on the Mammoth telescope for more than 3 hours now. CNN's John Holloman has been keeping an eye on the spacewalk. He joins us now with an update. John?
Brian, things are going very well. The astronauts have had 3 nights of spacewalks, and what they're doing right now is cleaning up after the successful replacement of the telescope's main eye. The wide field and planetary camera is located just above the gyroscope unit in the telescope, and the astronauts in space tonight pulled out one version of the camera and plugged in a new one. We can take some pictures and show you how it looked just a few minutes ago as the astronauts were in space working on this project. After it was done, astronaut Jeff Hoffman, just about 5 minutes ago, replaced the lens cover, the mirror cover rather, on the old and now replaced wide field and planetary camera. As he did this, he was standing on the Canadian-built robot arm out over the wing of the space shuttle. He was not in the cargo bay at all. That's one of the cargo bay doors that you see underneath him. He was up out of the cargo bay over planet Earth as he replaced this mirror cover. Now that that's done, this version of the wide field camera can be stored in the shuttle's cargo bay. The astronauts are probably, in fact, at this moment, involved in the process of doing that, putting it away. It'll come back to Earth where it'll be looked at by scientists and perhaps refurbished and maybe even someday sent back up into space on a future telescope upgrade mission. The astronauts have one more thing to do after they stow this camera in the cargo bay. They're going to go up to the top of the Hubble Space Telescope and add some new equipment to equipment that's already there that will allow the telescope to better look down at planet Earth and make sure, or rather fly over planet Earth and be in the right attitude connected to the Earth. This is kind of interesting, Brian. Right now in this picture, Jeff Hoffman moving out on the robot arm, making either some home movies or some still photographs of the work that he had just done as he was backed away on the robot arm by Swiss astronaut Claude Nicollier. And it's interesting that the astronauts, at the successful completion of at least one part of their mission, able to take some pictures to verify that they really were up in space after all. Right now, the shuttle is about to fly over Australia. It's flying upside down as far as the Earth is concerned. The payload bay doors are open, and the astronauts could look up over their shoulders and see the Earth down below when they get there. we'll be back with more live coverage of this as the mission continues tonight and in future nights. Brian?
Okay, look forward to that moments from now. We're covering the Space Shuttle Endeavour, and we invite you to stay with us. We're getting more live pictures from the Space Shuttle Endeavour, 320 miles straight up, and John Holloman's here to update us. John?
Brian, the mission so far this morning has gone very, very well for the astronauts. Here's what's going on in space right now. You can probably see astronaut Jeff Hoffman is virtually upside down on the Canadian robot arm. He's at the top of your screen, and the arm is sort of dangling down in the middle of the top of your screen in the picture. Underneath him, Story Musgrave, the payload commander, is assisting as the two of them have already lowered the old wide-field planetary camera down into the cargo bay of the shuttle, and they're locking it into place now. It's very important that this camera be not jostled as it comes back to Earth, because the NASA and other scientific and astronomical experts will be going over that camera with a fine-tooth comb, or the scientific equivalent of that, when it does get back to Earth in about a week from now. And it'll probably be, or potentially at least be, updated. And our live picture from Endeavour, as you can see, it shows those astronauts hard at work out there in the cargo bay, putting the old camera back where it should be. We asked a little while ago to invite other viewers to join our conversation. We have a caller now on the line from Honolulu. Go ahead.
Hello.
Yeah, go ahead. You're on the air.
Okay, I have a couple of questions. We're calling from Honolulu, and I was just curious about whether they are using the EMB jetpacks that they have used on previous missions.
Nope, they're not. There's no need to do that for this kind of spacewalk, so they're not using the jetpacks. What's your next question?
Second question is, we know that they're visible from various points on the Earth. We were curious about how to locate when it's visible, or if it will be visible from where we are.
Okay, I'll try to keep you posted from time to time. The fact is, the shuttle is traveling at 17,000 miles an hour, and it goes around the world every 90 minutes. And what I'll try to do is the next time that if I can see on a NASA graphical map that it's in your neighborhood or is going to be in your neighborhood, I'll let you know. Every time I see where the shuttle is relative to the Earth below, I try to point it out. And so yeah, we'll continue to keep you updated. Do you have another question?
No, that's all. Thanks a lot. We love the coverage.
All right. It's fun to provide the coverage. It's fun to participate in it. If you have a question about astronomy, our colleague Anita Kern from the Fernbank Science Center here in Atlanta is also available. Why don't we listen in for just a moment to the astronauts, Anita, and see what they're talking about as they complete this part of the mission.
It's Orbit Ops Checklist 5-9.
NASA has more checklists than anybody.
Okay, we copy Houston. And if they satisfactorily get it stowed, are we going to need to do the 2200 maneuver, or we'll be able to go to the 2300 maneuver?
Stand by, I'll check.
Aft 1 foot.
You'll see the robot arm, I believe, move to down toward the telescope by about a distance of 1 foot now, as the astronauts continue their work out in space. Our next caller is from British Columbia. Go ahead. British Columbia, you're with us on CNN. Go ahead. Hello, British Columbia. I guess we've lost our caller there.
Oh, you got me.
Okay, go ahead.
My name is David Tim. I'm in Greenwood, British Columbia. I'd like to just generally congratulate the NASA people on what's coming off as a very successful mission. And my question, actually, I got two of them. One would be on the focal distances that it's capable of, assuming that it's got good vision. For instance, if you pointed it at the moon, would it be capable of very detailed information coming back? And my second question would be, how do they orient it, aim it to different projects, stars, or nebula, whatever?
Okay, they aim it through a series of reaction wheels, and I'm not exactly sure how reaction wheels work, but Anita, you may know something about that. The other question was focal distances. For example, could it be pointed at the moon? Anita?
You wouldn't want to point it at the moon because it's too bright. It's really designed for faint objects in outer space, so we wouldn't ever point it in that direction. But the WIFPIC, the wide field planetary camera, when it's pointed, if it were pointed at the moon, it would take about 100 different shots to give you a full moon picture.
All right, Anita, thanks. You can see now the astronauts are removing the handhold from the original wide field and planetary camera, which is now safely mounted inside Endeavour's cargo bay for its return to Earth. We're going to take a break as the astronauts continue to clean up their work there, and somewhat later in the morning, probably within the next hour or two, we'll see the astronauts up on top of the telescope doing something that American spacewalkers have never done before. Stay with us. Our coverage continues from space, from Endeavour, and from CNN. Welcome back to our live coverage from Space Shuttle Endeavour of the Hubble Space Telescope repair mission. There's the picture from space right now. Astronaut Jeff Hoffman on the right is back out at one side of the storage compartment for the wide field planetary camera. His partner, Story Musgrave, over to the left, and they're just packing it up in a box for its return to Earth. We have another phone caller from California. Go ahead, please.
Hi, my name's Randy Gordon Gilmore from Benicia, California, and I had two questions.
Okay, go ahead.
The first one was, the astronomers have mentioned that the Hubble has about 10 times the resolution of the Keck telescope.
Yeah.
And I was wondering if that's taking into account the same type of computer enhancements to both types of pictures, or if the Hubble is just inherently has more resolution because of the lack of atmosphere.
Anita, go ahead with that one.
It's the latter part of your question. It is inherently has greater resolution just because of the lack of atmosphere.
In addition to rotating 100. Okay, and thank you. And my second question was, I was wondering...
Whoops, that's too bad. We lost our caller from California before he could ask his second question. Let's listen in to NASA's coverage now live from Endeavour of how the mission is going.
Installation, but both crew members will ride to the top of the telescope on the robot arm.
You want me to clean up that, Jeff?
Okay, we've got time for a quick call from Illinois. NASA commentator Kyle Herring was just saying that he was telling you something that I had been telling you for a while. The astronauts are going to take that ride up to the top of the telescope. Illinois, go ahead. You're on the air.
Yeah, I've got a question for the astronomers. I want to know how long will it take the astronauts to get used to the Earth's gravity after their 12-day mission? And had the effects of weightlessness on the astronauts in the past given them any problems, such as headaches or back problems?
Okay, let me answer that. I'm not an astronomer, but I'm somebody who's talked to the astronauts after their space flights in the past. It doesn't take them very long to readapt to Earth's gravity. As soon as the shuttle lands, particularly after a long mission, the last mission before this one was a medical mission, and the astronauts were pulled out of the space shuttle on stretchers and taken off to a medical facility because they wanted to see how long it would take them to readapt to gravity. The scientific results of that study have not been made public yet, and in fact are probably still being analyzed by scientists at NASA, but it turns out that within a day or two they can go about their normal duties and probably could do it even sooner than that if their managers at NASA would allow them. Brian, go ahead. Back to you now.
Okay, thank you very much, John. Continued coverage of the spacewalk coming up moments from now, but believe it or not, there are other...
These commercial messages will be joined by CNN's John Holliman to bring you extended live coverage of the U.S. Space Shuttle mission to repair the Hubble Space Telescope. Stay with us.
I'm just going to match the here.
And welcome back to our extended live coverage of the U.S. Space Shuttle Endeavour, which is on a little repair mission in space. And joining me here to analyze all of those things that are going on up there in space is John Holliman. Thanks for coming again.
Well, Bettina, this is fun. The space telescope, the space shuttle, more than 300 miles above us right now, flying over the Pacific Ocean toward Central America. It'll be over Africa again in about 25 minutes. It's amazing. It's hard to conceptualize an object moving at 17,500 miles an hour, but that's exactly what's happening. And you wouldn't think if it were moving that fast you could see a picture this clear, but we can. This is the picture of the cargo bay of the space shuttle as it Endeavour flies over darkness. In the upper right-hand corner of your screen, astronaut Story Musgrave, I believe, is the astronaut visible. He's has been working on the side of the telescope, and what's happened in the past 2.5 hours is that the astronauts have managed to replace the one part of the telescope that has provided the most pictures to us back on planet Earth in the 3.5 years the telescope has been up. Let's listen to what's going on right now.
Through that rotation.
The telescope is being spun on the turntable, which it sits on back in the back of the cargo bay, because the wide field camera replacement has been completed. This is in preparation for the final thing the astronauts are going to do today, but I'd like to review for our viewers what's happened in the past couple of hours before we look ahead into the future. The astronauts, Story Musgrave and Jeff Hoffman, went out, picked up, removed first the wide field planetary camera, and stuck it out over the wing of the space shuttle, just sort of hooked it out outside the cargo bay, and then they went down into a compartment that you can see visible, the bright orange thing in the middle of your screen, opened that compartment up and pulled out a new and improved version of the wide field planetary camera, took it out on the robot arm over to the side of the telescope, plugged it into the gaping hole that was left by the old camera that was removed, and in the past 25 or 30 minutes they've taken that now disabled older camera and put it back in that compartment and closed the top up, ready for its return to Earth. The new camera has been connected to electrical cables and grounding straps and TV cables to get the TV picture from the camera over to the radio transmitters that send it back to Earth. And everything seems to be working just fine.
Why was it necessary to replace this camera?
Well, you remember, Bettina, the main mirror in the base of the telescope has been ground to an improper prescription, and so it's out of focus. What they did with this new camera, there's a picture of the new camera now as the astronauts were plugging it in to the side of the telescope about an hour ago. The new camera has a lens that is ground to the opposite mistake of the mirror in the telescope, and what people tell me that's going to result in is much clearer pictures of the planets in this solar system than we had available before. So it was necessary to do that to give the telescope better pictures. And the astronauts, as you can see in this videotape that we recorded just about an hour ago, were very carefully, very slowly plugging in the new and improved wide-field planetary camera. You see Jeff Hoffman on the robot arm over to the left.
Now installed,
and on the right, you see Story Musgrave, the payload commander. These two astronauts had been training for years, literally, to do this specific job. They thought they were going to take about an hour longer to do it than they actually took. And so what's going on in space right now is that they are preparing. The telescope is spinning around 180 degrees. The ground controllers say it'll take it about 12 minutes to make that maneuver. And you can sort of see the movement very slowly on the turntable. The telescope will be tilted toward us. The top of the telescope will come toward where we are just a little bit to lower the top surface a few feet. And then both astronauts, Musgrave and Hoffman, will hook up together on the end of the robot arm. It will extend to its full height, and they'll be up on top of the telescope looking down at a couple of pieces of equipment there called magnetometers.
And what are they doing?
Well, those magnetometers, there are a couple up there already that are not working as well as had been expected. Their job is to provide the telescope with an indication of where the Earth is. The telescope, for it to send pictures back to Earth, has to know where Earth is, and it doesn't really have a camera to look at Earth. And these magnetometers detect the magnetic field of the Earth. And as long as they're working, the telescope always knows where we are down here. But they wanted to improve the ones that were there with new ones. This was not something they had anticipated needing to do. And so these magnetometers are in an out-of-the-way place. The reason they're going to have to do this fairly exotic maneuver way out at the end of the arm, as extended as high as it can be, is because they never thought they'd ever have to go that high on the telescope to do anything. And they'll take the new ones and bolt them on top of the old ones. And then they'll take an electrical cable out of the old ones and plug it into the new ones. The bad ones are going to stay up there with the new ones just mounted on their backs.
If you look at the whole mission, all these 5 spacewalks that are scheduled, how difficult is today's mission?
Well, I thought that the mission last night that we broadcast live to our viewers involving the solar panels was the most difficult. But my colleague Tony Clark, who runs our bureau in Dallas, has been with the astronauts in training for this mission. He sent me a message yesterday and said the astronauts told me this was going to be the most difficult part of the mission. The reason for that being that this camera has some very critical parts that you're not supposed to touch because you could misalign the parts. And one of those parts the astronauts had to touch today. They had to remove a protective cover from a small mirror, maybe 6 inches by a foot, out at the end of this camera because it couldn't go into space without a protective cover on it. So that cover was removed by the astronauts, and luckily, or perhaps because of very good training, nothing happened to it. It's still lined up just the way they hoped it would be, and it's now deep inside the Space Telescope, ready to do its work.
How long do you think will the spacewalk last today?
It was supposed to last for 7 hours, but that counted on the fact that they were going to have a little trouble moving this camera around in the cargo bay. As it turned out, they got the job done about 30 or 45 minutes ahead of schedule. So it could be that they'll be out for another 2 hours. The original go-back-in time that NASA had told us to expect was about 3 hours from now. But they may be able to end the mission as much as an hour ahead of schedule. Let me show you something while we're here. I'm going to send our director a curveball now. This is a photograph taken by the Hubble Space Telescope of the planet Saturn. And if we can zoom in on it, you can see what the quality of pictures now taken by the Hubble Space Telescope with the old version of this wide-field camera is. This is Saturn. You can see the rings of Saturn here. And this is a storm on the surface of the planet Saturn that is a storm apparently involving ammonia crystals that are going in space. I talked to an astronomer a few minutes ago who said that with the new camera installed and with the new optics involved there on the telescope, this will be much more clear. The edges of this storm will be much better defined. These white spots on Saturn will be just gradations of color. And so what we're going to end up with is much clearer pictures from the Hubble Space Telescope than we've ever had before, and they tell me that this picture of Saturn is about the clearest picture of that planet that's ever been taken by anything made by human beings. So the potential for this is really quite remarkable.
Okay, we'll have more on the Hubble space mission and the little repair job, to call it, and annoy a few people at NASA. We'll be back in a moment, but first let's take a short break. We continue our extensive live coverage of the repair mission in space. John Holloman again. How difficult is it for these astronauts to operate in space? They've been out there for hours, they will be out there for hours. What if they suddenly feel this urgent need to go to the bathroom? How does that work practically?
I talked to the man who manufactures the spacesuits that they wear, and there are two things that the astronauts can do. And I think they have both options available to them. They have a diaper-like device, which will allow you to urinate. There's also, at least for the male astronauts, a container for urine that is part of the suit that they can sort of whip into place if they need it. But the astronauts, because the atmosphere inside the suit is very low humidity, that's generally not a problem. They don't perspire. They don't build up an excess of water in their bodies. They have little bags inside the space helmet that have liquid in it that they can drink, but it's sort of complicated to manipulate around and get the straw in your mouth so that you can drink when you need to. So they're pretty self-contained there for up to 8-hour periods, according to the experts at the company that make the spacesuit. And
what is with oxygen? How do they get oxygen?
There are two big oxygen tanks on the bottom of the spacesuits that they wear, and when they go into the airlock, which sometimes they have to do to get additional tools and additional parts, there's an oxygen hose that they can hook up to those tanks and refill them. On the spacewalk last night, we found out the following day, one of the astronauts was ordered to do that, just to top off his oxygen tanks. Process takes about 30 seconds, and just in case there was a potential he was going to run out because of the work that he was doing, he filled up both of his tanks and he was fine. But they're capable to stay out at least 8 hours. I wanted to show you one more picture taken by the wide-field planetary camera aboard the Hubble Space Telescope. This is a picture made by the old camera, which is coming back to work now. It's what you see is this ring, sort of the yellow ring, is described by NASA as a huge disk of matter encircling a black hole at the heart of a galaxy known as NGC 4261. This, the black hole, the ring of matter around the black hole, had never before been seen by human beings. The Hubble Space Telescope wide-field planetary camera was able to take this picture, and again, now that the new camera is installed, if it works, when they open the telescope's aperture door up, NASA will take another picture of this same galaxy, and we'll be able to see the before and after, and see just how good this repair of the camera is. The astronomers that are working on this, though, say it's remarkable that the telescope has been able to do what it's been able to do so far.
How big is it?
And the telescope itself, it's 43 feet long. I guess that's about 11 meters. And at the base, it's 14 feet across. You'll have to do
like
the
4 meters.
4 meters, yeah. And the main mirror is about 3 meters across inside. It's by standards, when you think of everything being so huge on the ground, it's not that huge a piece of equipment. It's the size of a school bus. But compared to other telescopes outside the Earth's atmosphere, it's the best one we've got.
How do they get powered? How does this telescope?
In Europe, Japan, all over the world, including the United States, there may not be money to do one better than this. As you can see that from these recorded pictures, the astronauts out there in sunlight enjoying their work today. We'll be continuing to follow their progress. The next big thing for them to do is to replace a telephone booth-sized item tomorrow at about this time, which contains corrective optics for all the other cameras and instruments aboard the telescope, including the distant object camera that the European Space Agency has manufactured, which has been getting good pictures, but will be getting even better pictures after tomorrow night's fix-up.
Well, we've got lots of more to come here, but first let's take a short break. Space Shuttle Endeavour continue their third walk in space. They are performing a repair job to refocus the Hubble Space Telescope. A short while ago, the astronauts installed a new camera on the telescope. And that's world news for now. I'm Bettina Lüscher. We'll have live coverage of the U.S. astronauts on their walk in space just ahead. Thank you for watching.
Roger, and the MLI went down over the electronic unit. Good, great. Yeah, I watched it go. Beautifully. But I had to manage it, you know. Yeah. Glad to touch. Really good having you here. Well, it spotted that wire. That wire would have been blind to you. Absolutely. No way from your vantage point to send it. You could have spotted it. That should actually tuck underneath. The Velcro isn't attached there. Fox, can you bring me in a little bit? Sure. It can't tuck underneath. There's a plate there. There's a plate that sticks out. How about, the way I remember it was underneath that plate, there was the Velcro. Yeah. Well, on the telescope, but it doesn't tuck underneath the box. You want to look at it? I'll back off. I'll back off and you look at it. Okay. Not like the Mako. See that little plate there? There's nowhere to go but you're right there. That's all the Velcro there is. That's all there is. Okay. Now, Fox, if you'll bring me down a little bit, I'll try to get this connector. Okay, coming down a little. Oh, boy. Okay, where'd it go? Oh, story. Oh, there it is. Good. Yeah, okay. Got some memory to it. Yeah. Now, it's... If you want...
And welcome back. We now join CNN's domestic network for continuing live coverage of the U.S. shuttle mission to repair the Hubble Space Telescope. And CNN's John Holliman provides commentary on the spacewalk.
We copy, Tom.
Okay, let me get in which position here. Connector tool wouldn't do anything here, would it, Story? But what is that? Just a collar? That's a collar. Oh my goodness. Yeah. All it'll do is work on the collar. Do you want to get the connector and I'll do the collar?
Back to our live coverage of the mission of Space Shuttle Endeavour. This is what's going on in space right now. You're looking at a shot from the robot arm, the Canadian-built robot arm, of Endeavour as astronauts continue to replace magnetometers on top of the Hubble Space Telescope, something that's never been attempted before. In the background, you see planet Earth rotating beneath the astronauts. We're going to take viewer phone calls now. We have a caller in Ohio who has a question. Go ahead.
Yes. First of all, I'd like to say bravo to CNN and for being such an objective television station to have this on there. And I'd like to say bravo to Story Musgrave for showing people at 58 you can still do anything. I have two questions. One would be when they're trying to find the beginning of the universe, the wave, I guess this is for the astronomers, are they using some of Dr. Gurnet's from JPL plasma physics instruments? And the second question could be answered by either or the whole panel, is what direction is space heading in, and how could somebody in college now prepare themselves for that future of being an astronaut?
I'd like to put both of those questions to Ed Weiler, our NASA representative on the phone. Ed, did you hear both the questions?
Let me answer the second one first because I didn't understand the first one.
All right.
How could somebody today prepare for being an astronaut or the space program in general? I think what you want to do, obviously, is to major in, go to college and major in engineering or a hard science like physics, chemistry, astronomy, biology, etc. A graduate degree can't hurt. Good physical condition can't hurt. There's another route through the military, but I can't speak too well for that one because I'm not too familiar with it.
Okay. And Weiler, thanks very much.
Training doesn't hurt either.
Yeah, okay, thanks very much. I've polled all the members of our panel, and none of us understands the first part of your question, and we have other callers waiting. The next one in Edmonton. Go ahead, Edmonton. You're on with us. Okay, I think I just heard the caller in Edmonton hang up. Let's go now to Connecticut.
Hello.
Okay, we've got Edmonton back. Go ahead, please. You're on the air.
Yes. My question is, what type of telescope is the HST? Is that Schmidt-Cassegrain, the Newtonian, or some other type?
I'll take that. It's what's called a Ritchie-Chrétien telescope, which is a type of Cassegrain telescope, except unlike a Cassegrain, it has a hyperboloid primary and a hyperboloid secondary, which is pretty technical, but you asked a technical question.
Ed Weiler, the thing that's been fascinating to me, having been here live overnight for the past 3 or 4 nights, is the quality of the phone callers to see it. And when we do this call-in, people here understand a lot about astronomy, a lot more than I do, and it's nice that you're here to be able to speak their language. Our next caller is from Connecticut. Go ahead, please.
Hello, this is Bill Bourne from the Connecticut chapter of the National Space Society.
Hi, Bill.
It's hard to tell what's the bigger miracle of HST or getting connected to the dial-in show here. I'm happy to see that there's this much interest in the project and in the space program in general. I actually have a couple of answers that have to do with what, for example, what good gyroscopes are. And on the show last night, somebody was worrying or concerned about orbital decay. What caused the
I remember that.
The thing to the discarded piece to be
come back down to Earth.
Come back down to Earth, and the simple answer is that the atmosphere goes much higher than we normally think of, and it's caused by the drag.
Yeah, there's some atmosphere even out there where the astronauts are. Not enough to breathe, but enough to cause something to slow down.
And every little piece of atmosphere you hit slows it down and slows the piece down, and eventually it'll fall back to Earth.
Yeah, Ed Weiler, is there any concern on the part of NASA management at all that piece of solar panel might do any damage to anything?
No, because for two parts to that question. Could it do any damage in space? No, because it'll be it's so large. It'll be tracked by the NORAD, the U.S. Defense Radar System. They can track things as small as a good-sized bolt, and that's obviously bigger. So we'll know exactly where it is, and we would notify the Russians or any space shuttles or anything if it's getting close. But so that's highly, highly unlikely. In terms of re-entering the atmosphere, it is such a fragile thing, as you saw. It will easily burn up in the atmosphere. It's not going to hit anybody on the ground.
Okay, Ed Weiler, thank you very much. Stay with us for another 2 minutes, if you will. We'll take another break. Be right back with more phone calls and more of these beautiful pictures from space. Welcome back to our live coverage of the mission to Space Shuttle Endeavour. The picture that we're getting from NASA right now is a picture of the control room at the Johnson Space Center in Houston. Joining us from a room near that control room is Ed Weiler, NASA program scientist. And here in Atlanta, astronomers David Dundee and Anita Kern. We're taking viewer phone calls. Our next caller is from Ontario. Go ahead, please. You're on the air.
Hello. My question is, last summer up in northern Ontario, looking at the shooting stars, we noticed in the city of Toronto, you couldn't see shooting stars very well because of the city lights. But farther, about 200 miles north, we got a clear view of the shooting stars. We saw about 8 or 9 of them in about an hour and a half.
Was that the Perseid meteor shower you're talking about?
Yes.
Yeah.
Now, would the astronauts that were on the arm, would they get a view of shooting stars a lot better than we would on Earth?
Ed Weiler, take it.
Not a lot better, because the phenomena occurs fairly low in the atmosphere, like about 50 or 60 miles. So you're actually a little bit closer than the astronauts. On the other hand, the sky is darker in space. So I've really never, in all the things I've heard astronauts talk about, I've never really heard them mention very much their observations of shooting stars. So I really couldn't answer that.
All right. Good question, however. Thanks. Our last caller, probably for this portion of our program, is from Alabama. Go ahead, please. You're on the air.
Yes, this is Daryl Birdsong. I'm a medical student in Birmingham, and I'm interested in working as an astronaut in NASA. My question last night, there were viewers talking about wondering what people could see in space with the Hubble telescope, and one of the astronomers mentioned the Einstein cross. And I was wondering why the light emitted from an object behind a massive object would appear as a cross instead of as a circle encircling the massive object. I was wondering if one of the astronomers could explain that.
Anita Kern, why don't you take that one?
Yes, the Einstein cross is in the galaxy M51, and what you're actually seeing is a dust disk edge on. One of them is a little darker. The other one is probably tilted at a more of an angle, so it's not quite as dark. But there is some speculation that this is the dust and debris that could be fueling a black hole at the center of the galaxy. And if that's the case, it might even indicate that this dust and debris came from some sort of galaxy merger. This might represent a spiral galaxy that was absorbed or swallowed by the galaxy you see.
John has said, Weiler, I think the viewer's question really was the Einstein
He's talking about the quasar.
You're talking about the quasar. I'm sorry. Excuse me.
That's a quasar that's, like 50 times or 40 times further away than a galaxy that's intervening. And the viewer is correct. If the quasar were exactly in line behind that galaxy, you would see a ring caused by the gravitational field of the galaxy. But it is slightly out of line, and the galaxy is not a perfect sphere. It has, a non-spherical shape, and thus you see 4 images as opposed to a perfect ring. It would have to be directly behind it to see a perfect ring.
Interesting. All right. Well, Ed Weiler, thank you for joining us here. Thank you, Anita Kern and David Dundee here in the studio in Atlanta. Our coverage will, of course, continue. CNN Newsroom is coming up next, and some of the information contained in Newsroom will probably relate to this mission of the Space Shuttle Endeavour. We'll be back with more continuous coverage at the top of this hour. We urge you to stay with us, and if you'd like to call in, we'll try to take some more phone calls as the astronauts continue now to replace magnetometers aboard the Hubble Space Telescope. It's John Holloman reporting from Atlanta. We'll be back with more in a minute. Stay with us.
Floating high above the Earth, the crew of the Space Shuttle Endeavour remains hard at work as it continues its repair mission. This is another special edition of CNN Newsroom as we report on the historic mission to repair the Hubble telescope.
Officials with the National Aeronautics and Space Administration say they could not be happier with the astronauts' progress. All of the repairs done to the Hubble so far have been a success.
The Hubble is a 15-year project of NASA's to study stars, planets, and galaxies. When it was deployed 3.5 years ago, some mistakes in the way it was built were discovered, and they aren't easy to fix.
The telescope is 43 feet long and as big as a school bus. Right now, it's sitting upright on a turntable near the rear of the shuttle's cargo bay. That's where the repairs are being done.
One of the main goals was accomplished late Sunday night, early Monday morning. The telescope's source of electrical power, the 2 solar panels, had to be replaced. The 40-foot wings would shake when the telescope passed in and out of daylight. Strong vibrations interfered with the telescope. They also caused the panels to warp, and one of them wouldn't roll back properly for the flight home. Word from Mission Control was, get rid of it.
The job was given to astronaut Kathy Thornton. She stood at the end of the shuttle's 50-foot robot crane and was lifted high over the cargo bay. She then held the 350-pound panel over her head and let it go.
It is going to be 20 pulses.
The panel becomes the latest addition to some 6,700 other pieces of floating space junk.
Now, early Tuesday morning, the Endeavour's crew of 7 has been back at work for a third day of repairs. The mission to install a new camera that will get crisp, clear pictures of the faintest and oldest heavenly bodies.
And joining us now with details is CNN's John Holloman. Good morning, John.
Well, the third night of spacewalking has been very successful, Cassandra. What the astronauts have done on this third night is replace the main eyeball for the Hubble Space Telescope. The wide-field planetary camera was pulled out of its storage compartment aboard the shuttle, taken over to the side of the Hubble Space Telescope, where the earlier model of the camera had been removed. And what you see now is astronaut Jeff Hoffman on the left and astronaut Story Musgrave on the right, as they went through the final 20 seconds of the installation procedure to push the new camera into place. The astronauts and NASA managers who have been with us here at CNN tell us that if this camera works correctly, and they have every hope that it will, there will be some of the most clear and beautiful pictures of the planets and of the heavens that have ever been seen by human beings here on Earth. And NASA officials are just gloating with the excitement that has come. Right now in space, the same 2 spacewalking astronauts are out at the top of the Hubble Space Telescope, replacing a couple of magnetometers, which allow the telescope to sense where the Earth's magnetic field is located. By doing that, the telescope can continue to be in the right orientation toward planet Earth. This was a picture a few minutes ago from space as the astronauts went about the job of changing those magnetometers. So the mission at this point seems to be going very well.
Now, John, when will they actually turn on the new camera to see if it actually works?
Well, I won't be able to get pictures from it for 5 to 6 weeks because it has to be lined up, it has to be refocused along with the other parts of the telescope. They've already done an electrical check on the camera, and they've done what NASA calls a wellness check on the equipment associated with it, and everything seems to be going very well so far in the checkout procedure.
John, what about once this part of the mission is over, what's next?
Well, there's one more big optical instrument, something called the COSTAR unit. It's a corrective optics package. It's about the size of a telephone booth. The astronauts will take it out of a compartment near where the new wide-field planetary camera is stored out in the cargo bay, plug it in, just like a 600-pound telephone booth here on Earth. It will fit into a compartment in the size of the telescope, and if it works as well as the wide-field planetary camera is expected to, it will correct for the problems caused by the misground main mirror for all the other instruments aboard the Space Telescope.
All right. Thanks, John. That's CNN's John Holloman. Now, as you can imagine, Mission Control at the Johnson Space Center in Houston, Texas is a busy place. Dozens of people coordinating the movements of the shuttle astronauts as they work on the Hubble telescope.
One of those people is Ed Weiler, a scientist, or Wheeler rather. He's a scientist with NASA's Hubble program. He took some time out earlier tonight to talk with us by phone. First, we asked him about the importance of Tuesday morning's repair work.
It was one of the most critical moments in the mission because the wide-field camera that they put in tonight represents about 50% of the science that the Hubble was originally supposed to do. And that little mirror on the end there, which was exposed when Story took off the mirror cover, if they had bumped that just a tiny bit, it could have messed up the whole camera. So we were all watching, hardly breathing as they did that.
Ed, with this new camera in place, it's going to give scientists the ability through Hubble to do a number of things, explore time and space, I understand.
Yeah, I think some of the most exciting things, certainly for the public and especially the kids, will come out of this new camera. It's 50% of the science, but, you know, some science is easily explained to the public, some is not. And specifically, this camera produces a lot of the public interest science. For instance, looking back in time by looking back in distance. It takes light time to get from one place to another. For instance, when you look at the moon, you're not seeing the moon as it looks now. You're looking at it as it looked about 2 seconds ago. In fact, if the moon were vaporized right now, you wouldn't know about it for 2 seconds because it takes light time to get from the moon to the Earth. Same is true for very distant galaxies. With this new camera, we should be able to look back in distance about 10 or 12 billion light years, which means, in essence, we'll be looking back in time 10 or 12 billion years, because it took light that long to get to here at the Earth from those galaxies.
Now, Ed, how does Hubble stack up to other telescopes in operation, both on the ground and in orbit?
Hubble does not mean we don't need ground-based telescopes anymore. They do very different things. On the ground, you can build telescopes that are larger than Hubble for very specific tasks. Hubble's unique role in astronomy is its location above the atmosphere. The atmosphere blurs light. Thus, you can get much clearer pictures from space. For instance, Hubble can take pictures that are 10 times clearer than anything you can usually do from the ground. The other half of the story is because it's above the atmosphere, you can look at colors of light that do not get through the atmosphere. The atmosphere blocks a type of light called ultraviolet light from the vision of telescopes, and that's a good thing because ultraviolet light would basically kill human life on Earth if it got through. And that's about half of the science that Hubble does. It basically, in the ultraviolet, you're looking at objects that are much, much hotter than you can see in normal types of light.
And viewers watching this program overseas may be saying, well, this is a U.S. project. What kind of international applications does the Hubble have?
No, absolutely not. I'm glad you asked that question. The Hubble project is a cooperative project with the European Space Agency, so there are 13 European countries involved with NASA in this project. In fact, the solar panels that were put on last night were built and paid for in Europe. In addition to that, any scientist in the world can propose to Hubble to use Hubble, and we have many other countries involved in the Hubble program in terms of the science aspect. For instance, Australia, Canada, Mexico, in addition to all our European colleagues.
Earth to space, where the crew of the U.S. Space Shuttle Endeavour continues to take care of business in what has been, so far, a picture-perfect repair mission. Astronauts have installed a new camera on the Hubble Space Telescope. The new addition will help sharpen the Hubble's fuzzy focus. It was the third of 5 planned spacewalks, which will be a record. CNN International will have more live coverage of Endeavour's rescue mission later this hour. The record 5 planned spacewalks, astronauts on board the U.S. Space Shuttle Endeavour have installed a new camera on the Hubble Space Telescope. And that is world news for this hour. So stay tuned for more live coverage of the Endeavour mission coming up next on CNN International.
I called that out. I thought they all look good. Okay, thanks. The land-made plate in the side is flat. Okay. I know we don't use it, but it's...
And now we rejoin CNN's live coverage of the third spacewalk on the Space Shuttle Endeavour.
You got it? I have it. Okay, let me come back to you and straighten things out. Okay. How am I doing on clearances and things? You're okay. Come on down, Bud. Watch the inside with your feet. There you go. Give me a hand, I'll come over. Yeah. Basically, we just have to pass this underneath. Okay, stop, Bud, stop. coming up from, Jeff? This is fine. From the side you're on now, we'll be fine. Your right or your left? Well, the way I'm facing now in front of me. Just bring
Welcome back to our live coverage. We got to take you up to Endeavour's cargo bay, where two astronauts are sort of playing leapfrog out at the end of the robot arm. You see astronaut Story Musgrave on the right there, and on the left in his spacesuit is astronaut Jeff Hoffman. Musgrave and Hoffman have been attached together at the end of the robot arm to install two new magnetometers up on top of the telescope. That job is done. In fact, everything they were supposed to do is done. And rather than staying out in space for another 90 minutes, as NASA managers had planned to have them do to complete all their work, they're probably going to be coming back in within the next 35 to 40 minutes. But knowing astronauts as I do, I would be virtually willing to tell you they're going to stay outside as long as they possibly can. They may even find some additional reasons to stay outside. Let's listen to the conversation for just a second. They've had a very successful last 5.5 hours in space.
You see this, Tom? Yep. Nice, huh? Yeah, makes a really nice TA. And when they're not doing with bigger co-star, maybe that's a good way to go.
Mr. Musgrave talking about a training aid and one of the pieces of equipment there. We have many viewers who are on the phone with us and would like to participate in our conversation this morning. Our first call is from Washington State. Go ahead, please.
Hi, my name is Kyle from Seattle.
Hi, Kyle.
And I was interested, will the Hubble be able to pick up like perhaps a 10th planet or the black hole that they've speculated that will be, out beyond our solar system?
As of last summer, there were several papers given at a large national conference concluding that the existence of a 10th planet is 99% sure not to exist. And the reason they say that is that the motions of Pluto and Neptune are known well enough, and we can explain all of their perturbations, all of their odd movements well enough now not to need a 10th planet to be out there. So the likelihood of a 10th planet is quite remote. As far as a black hole close to our solar system, that's pretty unlikely as well.
All right, next caller is from Pennsylvania. Go ahead, please. You're on CNN.
Hi, I was calling, and I was wondering if any experiments will be done to confirm or deny superstring theory, and will any of the relativistic effects of going at such a high speed cause their aging to slow be countered by the effects of radiation that they are receiving at large doses up in space?
I'm not sure about the radiation as far as aging, but it is true when you accelerate, you do slow down or lengthen your life by some minuscule fraction of a second. Every time you get in an airplane, you do that. I don't know if you could say that pilots and stewardesses have much longer lives, but you might say they have maybe a millionth of a second longer.
Yeah, one of the problems that astronauts have is that they lose bone mass while they're in the zero gravity state much faster than people do here on Earth. It's a problem that Russian cosmonauts who have been in space for many months have had big trouble with once they got back down to Earth. That might be more of a problem to having a long and happy life than getting your life extended by traveling so rapidly. Next caller is from Florida. Go ahead.
Hello, yes? Can you hear me?
You sure can.
Okay. The question that I have is in reference to the measurements that they talk about the speed of light and the distances to the other stars and galaxies. Exactly what are the tests that they've done that have scientifically proven this in the recent time span with modern test equipment? And are they sure they're not just measuring the speed of the electron flow?
Test for the speed of light. You want to take that?
Anita Kern.
Oh, the speed of light is known pretty accurately from experiments as far back as the Michelson-Morley, where they can use a mirror that's actually able to be shifted, and they can measure the wavelength shift of fringes as they pass. I don't know if I can explain this on the air, but it is known fairly precisely.
Plus, it was in effect easily known from the Voyager spacecraft when they were out Jupiter and Saturn, the delay from the signal getting from there to here, and even the delay from the astronauts when they were on the moon.
They have a laser set up that they bounce off a mirror that's on the moon, and they can determine the speed accurately from that also.
So thank you both.
Pretty well known.
Okay, our next caller is from Hawaii. Go ahead.
Aloha.
Thank you.
I'm Fred Royalty. I'm a 9th grade science teacher at Lahaina Luna High School, and a couple of my students have some questions.
Okay.
They're worried about these astronauts, and one is wondering what would happen if one of the astronauts becomes detached, from the shuttle.
Okay, let me answer that first, and I'll get your next question perhaps if we have time after that. It's very unlikely that an astronaut will get detached. NASA has spent years trying to make sure that when astronauts go out in the cargo bay, they don't get detached. The way they assure that is that the first astronaut out gets on the robot arm and is immediately attached to that arm, and then he has a permanent attachment to the space shuttle that's impossible to break. And he is there, ready to go to work and ready to help the second astronaut when he gets out. The way they do this is the second astronaut generally hooks onto a tether, a line, that is also attached firmly to the shuttle, and there are multiple lines also. So if the second astronaut on his way out were to somehow become disconnected, the first astronaut on the robot arm would be able to slowly maneuver and grab that astronaut and bring him back down to safety. You would not move rapidly away from the shuttle if you did become disconnected to it. It would be a very simple process for the first astronaut outside to save the second one, and they never send astronauts out other than in pairs, or larger numbers than pairs. There have been as many as 3 outside on a U.S. mission in the past, and Russians have had even more astronauts out at once, I believe. So I think that's the answer to that. You have another question?
Yes. Raymond Lyons he'll be glad to get that answer. And then Rex Velasco has a question: if the Hubble isn't fixed by what is being done to it now, is there any plan to bring it back to Earth, or would there be another mission up?
There would be another mission up. NASA managers told me a couple of weeks ago that they'd have to kind of stop the schedule for other space shuttle missions and create a new mission, probably within a year, to go and do additional repairs. But if things continue the way they have for the past 3 nights, they're not going to need to do that. Everything seems to be going famously up in space.
It sure looks like it.
Yeah.
Mahalo and aloha.
Thank you again. Okay, we're going to take a quick break. We have some more phone callers waiting to talk to us. We'll be back. We'll hope to show you more live pictures from Endeavour as our coverage of this remarkable space shuttle mission continues. Don't go away. Welcome back to CNN's continuous coverage of the mission of Space Shuttle Endeavour. I'm John Holloman, along with 2 astronomers from the Fernbank Science Center here in Atlanta, and pictures from NASA. Right now, we're not getting live pictures from space. The pictures we're showing you are some that were recorded just about 40 minutes ago as the astronauts were up on top of the robot arm, replacing some magnetometers on top of the space telescope. And what a planet that is behind them. Just take a gander at that. We're going to take some more phone calls. Our next caller is from Pennsylvania.
Morning. 3 quick questions. Then I got your radio frequencies.
Great.
Any idea how hot a flat black surface would get with direct sunlight out there? Number 2, any idea who made the power ratchet tool? And did you find out what the story is on that orange spare glove that's floating around on the tool rack there?
Yeah, the orange spare glove is to help warm your hand if it gets particularly cold. It's a little add-on that NASA gave the astronauts because they were worried that the temperature out there where they're working might be 200 degrees below zero or something, and that would be bad. Here's a live picture now from Endeavour as the astronauts, by the way, are back moving toward the airlock and preparing to end this most remarkable spacewalk. Flat black surface in full sunlight might be as much as 200 degrees above 0 Fahrenheit. Why don't we listen for a minute to the astronauts as they talk to find out what it is they're talking about as they wind up this night of spacewalking.
In addition to taking an inventory of all of the tools and ensuring that they're all in the proper locations for tomorrow's spacewalk, The crew members have been asked to swap out the batteries in Story Musgrave's power tool. It did stop working while he was working on one of the fine guidance sensor doors after the wide field and planetary camera change out. He used Jeff Hoffman's power tool to complete that task.
Okay, we think you just leave it out, Jeff.
So the flight control team asked the crew to swap out the battery in Story Musgrave's power tool to see if that was the problem before going inside.
We talked about one side, the other side will be full except for the 2-inch, right? Let's see. Back. So I'm looking at the back. The back is clean on the 5.
As we continue to watch this picture, astronaut Story Musgrave is up next to the crew cabin. He's just standing there on the back of the crew cabin. He's still connected by a tether to the cargo bay. And astronaut Jeff Hoffman, still attached to the robot arm, is on the far right side of your TV screen. I was just looking in my Space Telescope driver's manual to see if I could find out the name of the manufacturer of the ratchet tool. I don't think it's there. I'll try to find out for you, though, before we talk again. Our next caller is from Illinois. Go ahead. You're on CNN.
Yes, John. Good morning to you.
Good morning.
I have a question here for David or Anita. Since the magnetometers have just installed are sensitive to the Earth's magnetic field and it's used to position the scope, if there's any changes or fluctuations in the Earth's magnetic field, does that also affect the scope?
The positioning of the telescope are the responsibility of the gyros on board, the pointing of the telescope. The magnetometers tell the telescope where the Earth is, so it's not really responsible for positioning. But
it's not
the fluctuations of the Earth's magnetic field is not enough over a 15-year period really to make much of a difference.
Because it's based on the direction of the magnetic field.
Not the strength of it necessarily. Good answers.
Yeah.
Our next caller is from California. Go ahead. You're on CNN.
Thanks.
Ultraviolet light is made ozone is made by ultraviolet light that comes from the sun, and there's probably one particular wavelength of ultraviolet light that actually makes the ozone. I was wondering, has NASA considered making a satellite that would produce this correct wavelength of ultraviolet light and make more ozone over the low ozone places?
That's an interesting question. I don't think NASA has considered it yet. I haven't heard about any research into putting something in orbit that would create what is necessary to make ozone. It's an interesting concept. I'll bet you there's some managers from NASA watching our broadcast, and maybe they'll take it back to the office and try to figure it out. Our next caller is from Ohio. Go ahead. You're on CNN.
Yeah, I've got a comment for you.
Okay.
I'm a senior high student in Mansfield, and I appreciate all the coverage you guys are giving me, because I've been watching it since day one from Hubble, and I mean, I'll be following it till it's all over. I mean, I just appreciate it because we're studying this in astronomy, and this is a great backup for it.
No kidding. I think if I were taking an astronomy course right now, I would be glued to the television for this Hubble Space Telescope mission, because the things that the astronauts are talking about will give you a greater appreciation for astronomical events in the heavens, I think. Quick update, the two astronauts are there about ready to end their spacewalk. They'll be going back inside the crew cabin of Endeavour probably within the next 20 to 30 minutes. We'll continue our coverage as long as they're outside, and we'll continue to take your phone calls. Right now, we'll take a break. We'll be right back. Hi, welcome back. You're looking at live picture from the Space Shuttle Endeavour. The shuttle is in sunlight now. They're adjusting a camera to the fact that the astronauts are in daylight at this moment. They've had a very successful past 5 hours, 6 hours actually, since their spacewalk started. The astronauts have replaced the wide field and planetary camera aboard the Hubble Space Telescope. They have added 2 magnetometers to the top of the telescope, what you see them doing right now. Story Musgrave on your left, Jeff Hoffman on your right is putting tools back in their toolbox so that they'll be ready for the other team, the next team of spacewalking astronauts tonight to use, if they need to replace the other optical improving instrument that's going to be added to the Space Telescope. We're taking phone calls from viewers all over the place. Our next call is from California. Go ahead.
Yes, my name is Eric Young. I'm calling from Oakland. Let's see, my question is, what sort of studies are being conducted, if any, to see if there are particles that exceed the speed of light? And one more question, is it mathematically possible to exceed the speed of light?
No. Okay, go ahead.
No experiments. Basically, according to Einstein's theories, for a particle to approach the speed of light, it gains mass, and at the speed of light, it theoretically would become infinite because it would take infinite energy. So only massless particles like photons travel at the speed of light.
And as far as studies about objects moving near the speed of light, the spectrometers on board the Space Telescope will be looking at the spectra of objects like quasars, which move something like 90% the speed of light.
Our next caller is from Washington State.
Yes, good morning. My name is Albert, and I'm calling from Seattle, Washington. And I wanted to know, when a picture is taken from Hubble and transmitted back to Earth and reconstructed, what is the terms of resolution of this picture when you compare it to a 35-millimeter photo or to the lines of resolution of a TV picture?
In a way, it is a TV picture if it comes from the wide field and planetary camera, which has a detector that is similar to the detector on a TV camera in it. And it's, I suppose, sent back using a digital transmission means, and the resolution ought to be pretty good.
About a tenth of an arc second, and I think Anita said earlier, it's equivalent to being able to resolve a pair of car headlights as two headlights at a distance of about 3,000 miles away.
Pretty good quality picture. Our next caller, Arizona, go ahead.
Yes, my name is Tim Wiley. I'm calling from Arizona, and I'm curious about the temperatures involved in space. My high school physics tells me that they are at 0 Kelvin, and space is 0 Kelvin temperature, which is absolute zero. And if my calculations are translations on the Fahrenheit scale, that's a minus 459.4 degrees Fahrenheit. What kind of protection do they have against that? How do that what looks like a rather small spacesuit to protect against unbelievably cold temperatures?
It's a very well insulated spacesuit. We had the manufacturer of the suit on with us night before last, I believe it was, and he explained that what they have in the suit is not a heater but a cooler. And the reason for that is the insulation is so good that outside cold temperatures can't get in. The temperature that the astronauts are working in the cargo bay is not absolute zero, we are told, because they are not in deep space. They are 300 miles above the Earth, and I guess there is some radiant energy, well, of course there is, from the sun, and the shuttle itself has the inside of the cargo bay doors of the shuttle. You can see one of the cargo bay doors, the hinge of it at least, in the upper right-hand corner of your screen right now, have radiators in them that provide heating and cooling using what sunlight there is, and that's stored, and that keeps the temperature there a lot warmer than absolute zero.
And deep space is not absolute zero either. It's usually 3 or 4 degrees at least above absolute zero.
Isn't it nice to know that astronauts, as well-trained as they are just as much tourists as the rest of us? Look at this. Story Musgrave has got the camera, the 35-millimeter camera, and he is taking pictures of his spacewalking partner right now as his partner prepares to finish packing up the toolbox and come back inside. Last night we saw pictures of the spacewalking astronauts being photographed from inside the crew cabin aboard the shuttle. They're like we are. We're going to take another break, and as the astronauts continue their work, we'll continue our coverage. Stay with CNN.
So we'll take a good look at this one to compare with MSS2.
If you're scared of heights, this is not the job for you. Hanging on the edge of a pole more than 500 kilometers above the ground. That's where the astronauts on the U.S. Space Shuttle Endeavour had to go for day 3 of their repair job on the Hubble Space Telescope, a job they've just wrapped up. The crucial part of the repair had to be done while the shuttle was on the dark side of the Earth. Astronauts slid a camera the size of a small piano into the Hubble, the first of several repairs aimed at fixing the telescope's nearsighted vision. And now back.
The Hubble mission to repair the bleary-eyed Hubble telescope is going better than expected, and that's helping to smooth over the controversy surrounding the company that built the now infamous flawed mirror. Perkin-Elmer, the subsidiary of General Motors, is that firm. In October, it agreed to pay $25 million to settle a Justice Department lawsuit. You're looking at live pictures here from the Space Shuttle Endeavour, and with the mission apparently going well, Perkin-Elmer's reputation may be on the mend. Yesterday, astronauts installed a new camera with special mirrors to correct the Hubble's flawed vision, along with 2 new solar panels. The Hubble is expected to stay trouble-free until its next scheduled checkup in 1997.
Space Shuttle Endeavour have completed their 3rd of 5 planned spacewalks to make repairs on an out-of-focus space telescope. CNN's John Holloman has the story.
They've done it again. The Endeavour astronauts had a complex job in space. Story Musgrave and Jeff Hoffman pulled the main instrument from the Hubble Space Telescope and replaced it. The wide-field and planetary camera provides more than half the pictures from the telescope. Balanced on the end of the robot arm, Jeff Hoffman pulled out the old camera. Story Musgrave, the payload commander, assisted on the right side. They stored the old camera temporarily on the side of the cargo bay, then pulled the improved camera from its storage locker.
Look at that baby. Beautiful, spanking new with We'll take some nice pictures with that.
Hoffman pulled the new camera over to the telescope, and he and Musgrave installed it during darkness. The most critical part of the job was removing a protective cover from the camera's mirror. Later, both astronauts were lifted to the top of the telescope to add 2 instruments which will tell the telescope where the Earth's magnetic field is located. The unusual maneuver gave both spacewalkers spectacular views of the Earth from high above the shuttle. As they finished their work, ground controllers asked the obvious question.
Every day it's becoming more and more of a can you top this?
They'll certainly try. Coming next, a spacewalk to add a telephone booth-sized package of corrective optics that might properly focus the rest of the telescope's instruments. John Holloman, CNN reporting.